Okay, welcome to this video where we're going to be going through a revise along with me for the next few hours looking at topics that can come up on paper 3. And obviously we're just going to go over some common exam style questions. We're not going to be covering the entirety of what can come up in the checklist, but do check out all the videos that I've posted recently as a priority over this one. So just before this, we've gone through a final predicted paper. And the video before that, I posted a question on every topic that was missing from the checklist that hasn't appeared. So those two videos should be your priority, but if you've done both of those and you just want to do some revision with me tonight, then stick around for this video. Now we've got a lot to get through, so let's get started. Okay, so when looking at the order of operations, we just need to remember our rules and which ones go first. So this one says put a pair of brackets in each statement to make the statement true. So the first one here says 2 times 7 squared, take away 2, and that equals 94. So first of all, you would do the indices, so you'd do 7 squared. So if we were to work this out without any brackets, it would be 2 multiplied by 7 squared, which is 49, and then we would take away 2. So 2 times 49, as we do the multiplication next, would equal 98. Take away the 2 would equal 96. So obviously that doesn't equal 94 at the moment. Now if we are going to put some brackets in, normally we can figure this out because normally there is only one place or maybe sometimes two places in order to put the brackets. Now this one here, you could put it around the 2 times 49, and if we put it around the 2 times 49, that would obviously just be exactly the same calculation. We'd get 98 and then take away 2. So it can't go there, and if we change it to the other position it could go in, it would have to go just here, so around the 49 minus 2. So this time we would do the brackets first, and that would be 2 times 47. And 2 times 47 equals 94, so that works. So we would put our brackets around the 7 squared minus 2, and that would enable us to have 2 times 47. On to the next one, we've got 16 divided by 2, and then add 6, add 2, and it says it equals 4. So if we were to do that at the moment, we would do the 16 divided by 2 first. So if we work this out and see what it comes out as, and then you would add 6 and add 2. So at the moment we do division before we do addition, so that would be 16 divided by 2 would equal 8, add 6, add 2, and that currently equals 16. That's obviously a lot higher than the 4 that we're looking for. So in order to get this right, obviously we're not going to put the brackets around the 6 divided by 2 because that's what we would do first anyway. So if we try something else out, let's just try the next two numbers along. So if we were to put the bracket around the 2 plus 6 maybe, let's just have a look and see what we get. So that would be 16 divided by 8, and then we would add 2. Again, we do the division first, so 16 divided by 8 is equal to 2, and then we add 2 to that, and we actually get the answer 4. So there we go, there's our answer. So we put the bracket around the 2 add 6. Of course, if that didn't work, we could also try putting the bracket around this plus 6 plus 2. So 6 add 2 would equal 8. So you'd do the 16 divided by 2, which would equal 8. But then you'd add 8 and you'd get 16. So that would obviously not equal the 4. So there we go. That would obviously give us our answers. So you've just got to test out the brackets and see if you get the correct answer there, remembering your order of operations. Okay, so this question says the table shows the temperature every 4 hours one day in December. And we can see the table. It says write down the time with the lowest temperature. So when we're looking at negative numbers here, because we've got some negative temperatures, we're looking for the largest negative. So the largest negative in this table here is the negative 4 degrees, as that is colder than negative 2 and negative 1. So the time there next to that is 6 AM. So we would just say 6 AM is our lowest temperature, or the time with our lowest temperature. It says work out the difference between the temperature at 2 PM and 6 PM. So if we find those, we've got 2 PM here and 6 PM here. And the difference is therefore between 8 and 5. Now the difference, when we give a difference, it's always a positive number. So although the difference there, it goes down by 3, we don't say negative 3, we say the difference is 3 degrees Celsius. So we take the bigger number, we take away the smaller one, so 8 take away 5, and that gives us 3 degrees Celsius for our difference there. On to the next part, it says between 10 PM and midnight, the temperature went down by 5 degrees Celsius. Work out the temperature at midnight. Well, the temperature at 10 p.m. is -1 degrees, and it's going to go down by 5. So we've got -1, we need to take away 5, and that's going to equal -6. So our answer is -6 degrees Celsius. So there we go, we had 6 a.m. for part A, 3 degrees for part B, and -6 degrees Celsius there for part C. Now when we're working out a fraction of an amount, we just need to have a look at that denominator. If something is being split into thirds, it means it's going to be split into 3 different parts. And if we were to draw this, and I'm only going to do this for this first example, but if we were to draw a little example with a little bar, if we were to split this bar into 3 portions, there we go, and I've not drawn it perfectly, but they should be equal parts, then that would be splitting something into thirds. So if we were going to figure out what number was going to go into this bar, bearing in mind we're splitting 48 into thirds, then in order to do that I would divide by 3. So to start with, I would do 48 divided by 3, and I just need to work out what that is. So if you need to, you can obviously do some division to the side. So I would go for bus stop division if you didn't know what this was off the top of your head, and we'll do 3's into 48. 3 goes into 4 once with a remainder of 1, and it goes into 18 6 times. So 16 would be each of our 3 parts. So if we put the 16 into each of our bars, that would be splitting it into 3. Now this question only wants to know what 2/3 are. So out of those 3 parts, we're only actually looking at 2 of them. So I would take my 16 there, find the total of the 2, or in other words, I would do 16 times 2. So in terms of just working out the numbers, we've got 48 divided by 3, which is 16, and that is equal to 1/3. So 1/3 would be 48 divided by 3. And then for our 2/3, which is what we are looking for, we'd take that 16, multiply it by the 2 parts we're looking at, and we'd get an answer of 32. And again, we could label that on the diagram just there as 32. So thinking about what we've done here, all we've actually done is looked at the denominator, and we've established that it's going to be split into 3 parts. So to do that, we've divided by 3, just here, divide by 3. And then because we want 2 of those, again, just looking at the numerator there, we've multiplied our answer by 2, and we've got a final answer of 32. So this says an advert for a tuition centre states that 8 out of 10 students passed their test first time. It says James talks to 56 students who had used the tuition centre and found that 44 of them passed the first time. Does this support what is said in the advert? And you must show how you get your answer. Now, there are 2 different ways to think about this. I'm going to do it as a fraction of an amount. So at the moment, if 8 out of 10 students pass first time, that as a fraction is 8 out of 10. And of course that could be simplified as well, but we'll have a look at the other fraction first. So it says here James talks to 56 students, and out of them 44 pass first time. So as a fraction, that would be 44 out of 56. So we want to compare these 2 fractions. We've got 8 out of 10 and we've got 44 out of 56. Now this is nice and easy to do because if you have a calculator, you can just type them both into your calculator and it will simplify it for you. So if we type in 44 over 56, if you don't have a Casio calculator, you can type in 44 divided by 56, but this simplifies the fraction for you and it comes out as 11 over 14. And that is in its simplest form. If we look at the fraction 8 over 10, again, you can obviously just simplify that, but you can just type it into your calculator. It will simplify it for you, and that comes out as 4/5. So as you can see, we have the actual answer, which is 11 over 14, when he's asked these people or these students, and the advert said that it was 4/5. So in terms of does it support it, we would say no, this does not support it, okay, as one comes out as 11 over 14 and the other one is 4 over 5, and therefore they are not equivalent fractions. Of course, if you didn't have a calculator, you could simplify them yourself, but we've used a calculator method here and just typing them in and just getting our simplest form straight away. Okay, so it says here is a list of fractions and we have our 5 fractions. One of these fractions is not equivalent to 1/5 which fraction? So obviously you can just simplify these without a calculator, but if you have a calculator, then you can just type them in. So you can either press your calculator button if you are using a Casio calculator, which obviously just looks like this with a little shaded box on the top, or you can just use a divide button. So for this one, you could do 2 divided by 10, or obviously just using your fraction button. And if we just type that in, obviously we can simplify this without a calculator, but that comes out as 1 over 5. For 8 over 40, that as well comes out as 1 over 5. For 7 over 35, we get the same again. And then our 15 over 80. Now if you type in 15 over 80, you'll see that that comes out as 3 over 16. So that one there is not equivalent to 1/5. Obviously it only says one of these fractions is not equivalent to a fifth. You'll find if you type this one in as well, we do get 1/5 for the 13 over 65. So in order to answer this question, we give the original fraction, not our simplified one. So 15 over 80 is the fraction which is not equivalent to 1/5, and that's all just typing it in on a calculator to get our final answer. So there we go, that's what we'd give as our final answer, 15 over 80. So this says find the highest common factor of 24 and 64. So a factor being a number that fits into these two numbers perfectly. And we're going to try and find the one which is matched in both. So I'm going to start with finding the factors of both these numbers. So I'm going to start with 24, okay, and then I'll have a look at 64. So I'm going to split this up into 2 halves. So 24, now the first 2 factors I always find is 1 and itself, so 2 and 24. And then looking at the 1, I always go one number higher, so I'll go for 2. I'll go for 2 and 12, and it's a really nice method of doing it because it starts to limit the amount of factors for each number. So in that first choice here, when I got 1 and 24, I'm only concerned with all the numbers between 1 and 24. But now I've got 2 and 12, I'm only going to look at the numbers between 2 and 12. So I'm going to start with the next number 3. 3 does go in, goes in 8 times, 8, 16, 24. And now I only need to look at the numbers between 3 and 8. So the next number 4, 4 goes in, it goes in 6 times. And now the only other number I have to choose from is between 4 and 6, and that number's 5, and it doesn't go in. So there we go, I'm happy I've got all the factors there. I've worked through it in a nice process there. Moving on to 64, we've got 1 and 64. 2 times 32. Now does 3 go in? Again, nice little trick here. Add together the digits in 64. So 64 over here, if we add together 6 and 4, 6 plus 4 is 10. And 10 is not, oh that's not a 10. 10 is not in the 3 times table, so it doesn't divide by 3. There's a little trick for seeing if something divides by 3. So I'll move on to the next number, 4. 4 does go in. Not very nice here. If you can't work that out, let's just do a little division. So 4 into 64 goes once, remainder 2, and it goes into 24 6 times, so it goes in 16 times. Quite a nasty one to spot there. So now I've only got the numbers between 4 and 16. 5 does not go in. 6 does not go in because 6 gets you to 60 and then 66. So 6 doesn't. Does 7 go in? No, it's 6 less than 70. 8 goes in, no, doesn't it? It goes in 8 times. There we go. So it'd be 8 times 8. Now I don't need to write down both of those now because I'm finished. There are no numbers between 8 and 8, no whole numbers that we're looking for. So we'll get rid of one of those 8s. And there is our factors. Now let's have a look. Which is the highest number in both? Now I'm going to start over here with the 24. So 24 doesn't go in, so not that one. 12 didn't go into 64, so not that one. But 8 being the biggest number here, look, does go into both. So our highest common factor there is 8. So I'm going to abbreviate highest common factor to HCF, and I'll just say the highest common factor equals 8. Okay, so 2 lights flash at the same time. One flashes every 12 seconds, the other flashes every 16 seconds. After how long will they both flash again at the same time? So let's have a look. Really all this is saying is, okay, so 12 and 16, when's that time going to be when they both flash again? So if we look at 12 and 16 and see when they both meet again at the same time. So 12, 24, 36, 48, 60, it's on to 16, 32, add 6 is 48, add 10 is 50, sorry, add 6 is not that. Let's have a look, add 6 is 38, sorry, add 10 is 48, and add 6 is 54, add 10 is 64. Okay, well, we've actually already got a match there, haven't we? We've got 48 on both. So the question said, after how long will they both flash again at the same time? This was in seconds, as it says in the question, 16 seconds and 12 seconds. So we're going to just make the statement, after 48 seconds. And there's our final answer. Okay, so when looking at time conversions, we could have questions like these. So it says, write 180 minutes in hours. So it's important to know that there are 60 minutes in an hour. So there are 60 minutes in 1 hour. So in order to turn minutes to hours, we just divide by 60. So if we just do 180, divide that by 60, and it gives us a whole number, we get 3 hours. So 180 minutes is equal to 3 hours. Now for this next question here, it's a slightly more complicated question. It says work out the difference in minutes between 1 hour and 32 minutes and 1 3/4 hours. So in order to have a look at this, obviously they're both a 1 at the start, so we're just looking at that 32 minutes and comparing it to 3/4. Now a couple of different ways that you could do this. You might already know how many minutes are in 3/4 of an hour, but you could do this in two different ways. Either we could work out 3/4 of 60, which would work out how many minutes it is, or we could do it as a decimal. 3/4, if you type it into your calculator, is 0.75, and you can just multiply that by 60. Now either way, for either of those, we get 45 minutes. So whichever method you choose, you're going to get 45 minutes, but that method on the right there is important because you need to know that when you're working out speeds and you have hours in the decimal form and you need to get it into minutes or vice versa. So actually all we're comparing here is 32 minutes to 45 minutes. So in order to get our difference between them, we'd do 45, take away 32, and it gives us a difference of 13 minutes. And there we go, that's the difference there for that question, and there is our final answer. Okay, so when looking at some compound units, sometimes we can have to convert between kilometres, hours, metres and seconds. So this particular question is quite a unique one, but it says to change 72 kilometres per hour into metres per second. Now if we think about this in a logical way, 72 kilometres per hour is 72 kilometres in 1 hour. Now if we write it like this, we can think about how we would make this conversion. Now instead of writing 1 hour, let's write that in terms of minutes. So that 1 hour instead would be 60 minutes. So 72 kilometres will be done in 60 minutes. Now what we could do is we could write that in seconds. So 72 kilometres would be equal to, and we'd need to multiply the amount of minutes by 60. And if we times 60 by 60, we get 3,600. So that is now in kilometres per second. Well, per 3,600 seconds. In order to get it into metres, we would want to change the kilometres. So I'm just going to write down here what we did. We times that by 60 to write it in seconds. And now we're going to turn the kilometres into metres. And to do that, we would multiply by 1,000. There are 1,000 metres in a kilometre. So that's going to mean it's 72,000 metres. And that's going to be in 3,600 seconds. Okay, so we're almost there. Now if we want to write this in metres per second, and that's per 1 second, we would need to divide by however many seconds we have. And if you have a look, this is obviously 3,600 seconds. So if we divide both of these by 3,600, that is going to be for every 1 second. And again, we're just doing this on a calculator. So 72,000 divided by 3,600 comes out as 20. So that's 20 metres, and that's going to now equal 1 second. And there we go. So that is going to be in units 20 metres per second. And that's how we go about changing some of these when we have compound unit conversions. Okay, so this question says a map has a scale of 1 centimetre to 14 kilometres. On the map, the distance between Manchester and London is 18.8 centimetres. What is the real distance in kilometres between Manchester and London? Well, it says up here that every 1 centimetre is equal to 14 kilometres. So if there was 18 centimetres, we'd just do 18 times 14. This is just 18.8. So that's not going to change the method. So all we're going to actually do here is 18.8 centimetres. We're going to multiply that by the 14 kilometres that every one of those centimetres represents. And if we type that into a calculator, 18.8 times 14 is equal to 263.2, and that is now in kilometres. So there we go. All you have to do is have a look at the scale and then multiply it up, or if you were going backwards, you'd have to multiply it down, or sorry, divide it down to get the kilometres back into centimetres. So if this was the other way round, we would just divide 263.2 by 14, and it would tell us that on the map it had to be 18.8 centimetres. Okay, so when we are writing a percentage as a fraction, it's very quick and easy for us to do. Now, whatever the percentage is, we're just going to put it over 100. Percent literally means per 100. So 3% means 3 per 100, or 3 out of 100. And there we go, that'll be my final answer. It literally is as easy as that. Now, of course, if the question says to simplify it, and you are doing this on a calculator paper, you can put your fraction straight into your calculator, it will simplify it for you, or of course on a non-calculator paper you just have to simplify it yourself. Now the next one below is a little bit of a strange one as it has a decimal in it, but we can still put that over 100. So we could write 2.5 over 100. And hopefully you know you're not allowed to have a decimal on top of a fraction, so we will have to go about changing this. Now if I type it into a calculator, 2.5 over 100, or 2.5 divided by 100, it'll actually just simplify that for me, and it comes out as 1 over 40. And of course you could do that on a non-calculator method anyway. You could multiply the top and bottom by 2, which would give you 5 over 200, and then simplify it from there. But of course, just typing this into your calculator makes it nice and easy, and we are able to turn those percentages straight into a fraction just by putting them over 100. Okay, so when we decrease by a percentage, now again, if you were going to do this without a calculator, you'd follow a very similar process to what we talked about at the start. So if we work that out quickly so we can see what the answer is, and then we can check our method using the calculator process. So if we work out 10%, just working out 10% of 80, which is 8, we want double that for 20%, so 20% would be 16, and to decrease by that percentage we would subtract it away from 80, so we would do 80, take away the 16 that it's decreasing by, and that would come out as 64. So we know our answer is going to be 64. Now let's have a look at applying our multiplier method. But again, obviously, if you had a non-calculator method, that's how you'd go about it. So again, if we think about 80 as our original 100%, but this time we're going to decrease it. So we're actually going to chop off 20% of that. So if this is 20% that we're going to decrease it by, and the overall amount was obviously 100%, what percentage is going to be left over? Well, 100% take away 20% would leave us with 80%. So the actual percentage that we're going to have is 80%. And if we're going to multiply to find out 80%, this time we're not going to multiply by a 1-point number, because obviously that would increase it, but we're going to multiply by a 0-point number. And the 0-point number that we're going to multiply by is the decimal version of what's left over. And we have 80% left over. So 80%, if we write that as a decimal, is 0.80, or 0.8, but I'll write it as 0.80. And that's the decimal that we're going to multiply by. So whereas before we added the 20% on, which would have been 1.20, and multiplied by that, this time we're taking the 20% off, which leaves us with 0.80. So that's all we're going to multiply by. So this is a bit of a strange one because it's 80 multiplied by 0.80. But if we do 80 times the 0.8, and work that out on a calculator, that gives us the answer 64. And there we go, we've got our match and we know that we've done the correct method. So our answer is 64, and our multiplier in this case was 0.8. So again, you've also figured out something else hopefully in this, and that is if you just want to work out a percentage of an amount by using a multiplier method, you can do it just like this. We've just seen that to work out 80%, we just times by 0.8. So although we're going to be using this for decreasing, you've also now got a method for working out percentages with a calculator. For example, if we wanted to work out 20% of a number, we could multiply by 0.2. If we wanted to work out something like 34% of a number, you could multiply by 0.34. Okay, so there we go. Another method that you can use for working out percentages of an amount. But let's have a look at another question before you have a go. Okay, so looking at a single digit percentage. Now we're going to decrease here by 4%. So if we want to know what percentage is left over, well, if we take away 4% from our original 100%, we would be left with 96%. So if we're going to decrease something by 4%, we actually are working out 96% of that number. And 96% as a decimal can be written as 0.96. So that is our multiplier that we're going to multiply by. So nice and easy, we get 240 on your calculator, multiply it by 0.96, and if we type that in, 240 times 0.96, the answer comes out as 230.4. And there we go, and that's our final answer. So to work out a percentage decrease, we figure out what percentage will be left over once that has been taken away, and then multiply by that decimal version, which we call a multiplier. Okay, so this says there are 200 students in year 11, 75 of these students are girls. Write down the fraction of the students that are girls. So again, this is actually just writing a fraction of an amount here, and we have 75 out of 200. So there are 75 that are girls, so that would be 75 on the top, and there are 200 students in total, so that is out of 200. Now, of course, it doesn't ask you to simplify it. It wouldn't be incorrect to simplify it though. So if you did simplify it, 75 over 200 on the calculator comes out as 3 over 8, or any other equivalent fraction for 75 over 200. But of course, if it doesn't ask you to, there's no point in simplifying it, so we may as well leave it at 75 over 200. For the next part, it says there are a total of 1,350 students in the school. One day, 108 of the 1,350 students are absent. Work out the percentage of the students who are absent. So in terms of doing this, we're going to use a very similar method to what I've done in part A. So I'm going to say 108 of the students out of 1,350 are absent. So in terms of writing this as a percentage of an amount, rather than actually trying to get a percentage straight away, I'm going to write it as a fraction of an amount like I've done in part A. Now all I have to do is type that in on my calculator. So 108 divided by 1,350, and when you press equals, you'll see it comes out as the decimal 0.08. Now that is the decimal version of the percentage. So if you want to turn that straight into a percentage using your calculator, you just need to multiply it by 100 and it will turn that into a percentage for you, and as you will see, that comes out as 8%. And there we go, that would be the percentage of the amount of students that are absent, and that was 108 out of 1,350. So this first one says a washing machine has been reduced in a sale by 20%, and then it says the sale price is £512, work out the original cost. And it's that language there that hints to us that this is a reverse percentage, working out the original cost. We're going back into the past. Now when we've got a sale price of 20%, that means something's been reduced in value. So what I do is I draw this little bar out and I think, okay, well I've got 80% and 20%. Okay, so I'm getting a little sale here, and we've got 20%, and we've got the original the new 80% there once we've got our little sale. So what we've got to think here is it gives us this price. It says £512 is the sale price. Now this 20% here, this little bit is always going to be our little discount. Okay, so that's the amount of money that we're getting off. There we go, so that's the discount, and this is the price we pay. Okay, there we go, price we pay. And obviously when it comes to real life, unless there is an absolutely enormous discount on, it's more than likely that we're just getting the little bit there, that 20%. So what we've got to do is read the wording and see what that is. So it says the sale price is £512. So that's the amount of money we're actually going to pay. So if we're going to actually be paying £512, that's the 80%. So straight away I just write down 80% equals £512. There we go, and that's the first bit of the process here. Now all we've got to do is, the thing is we don't actually want to know 80%, we want to know 100%. We want to know the original cost, the original 100 before that 20% was taken off there. So in order to do that, we've got to figure out what percentage can we turn this into, this 80%, so that we can turn it back into 100. Obviously there is a number that you can times 80% by, but without a calculator it's going to be really hard to work out. Now if we can get it down to 10% or 5%, that would be really useful because we can turn that into 100% quite easily. So 80%, you've just got to think, what can you divide 80 by to get 10%? Okay, and actually we can divide 80 by 8. So we can divide that by 8 and that would give us 10%. So if we divide that by 8, we'd also have to divide this 512 by 8. Okay, whatever you do to one side, you do to the other here. So in order to divide that by 8, we're probably going to have to do some written methods. So I'm going to use a little bit of bus stop division. So 512 divided by 8, and we're going to work that out. So if we go ahead and divide that by 8, 8 doesn't go into 5, but it goes into 50, up to 48, doesn't it? So that's 6 times. It goes up to 48 with a remainder of 3 there, leaving us with 32, and then 8 goes into 32 4 times. There we go, so 64. So 10% was 64 of that original cost. Now we can turn that back into 100%, because once we've got 10%, to get that back to 100, you would times by 10, and that would give us 100%. So 100% there, timesing 64 by 10, would give us £640. There we go, So our final answer there is 640. Let's have a look at another question, but before we do so, just a little note is if you did have a calculator here, once you'd identified that 80% was a 512 in this step right here, if you have a calculator, and I write this to the side, you could just divide by 80, so 80% on a calculator, you could do divide by 80, which will give you 1%, and then you can just times by 100. So it's a slightly different process there. It's a lot easier if you have a calculator, because once you get 1% times by 100, or just add 2 noughts on, and that'll get you to 100%. Okay, but that only works if you have a calculator there. It's probably unlikely we're going to want to do 512 divided by 80 and then times it by 100 without a calculator. Okay, so a new printer costs £288 once 20% VAT has been added on. Work out the cost of the printer before the VAT. Okay, so this is quite common type of question here because it's obviously used in business. Businesses can claim back the VAT. So if we have a look at what we've got here, when it's an increase in value, we do have to draw these bars slightly differently because although we've still got these two sections here, we've got the 20% being added on, but that was added on to the original 100%. So we've got 100%, the original cost, but now 20% has been added on this extra VAT. So in this question here, we've got the VAT, and that's the cost of the VAT. This is the original cost, or the cost without the VAT. And then you've got the total in this case, which is the cost plus the VAT, and that is 120%. So slightly harder when we've got an increase here, so we've got 3 to look at. Now the original costs there we're not going to be looking at because that's actually what we're working out here, work out the cost before VAT. So in this instance we've got either the 20% or the 120% down the bottom there once that 20% has been added on. So it says a new printer costs £288 once the VAT has been added on. So you've just got to ask yourself the question, is that the VAT that's been added on, or is that the price I'm actually going to have to pay with 120% down here? And that actually, if you read the wording there, a new printer costs £288. It doesn't say that £288 VAT has been added on, it says that's what it costs. So that is the 120%. So I'm just going to write down that statement, 120% equals 288. Now I'm just going to take the exact same approach here. I'm going to divide this down and build it back up, but it's slightly harder here. I've got to think, what am I going to divide 120 by to get 10? And if you think, what do you times 10 by to get 120? That's 12. So in order to get down to 10, I'm going to have to divide by 12. So if we divide by 12, let's work that out, divide by 12. Not as nice when you're dividing by a double digit, but we can do that with just using a little bit of bus stop again, just being nice and careful when you do this. So we'll do this to the side. What have we got? 288 divided by 12, and let's figure that out. So 12 goes into 28 twice, up to 24, remainder 4, and then it goes into 48 4 times, so 24 there is our 10%. Okay, so 10% equals £24, and then nice and easy from there, just like the rest of these questions, we just times it by 10. So times that by 10, and that'll get us our 100%. So 100% equals, and that'll be £240. And there's our final answer there. So obviously just making sure you write that with your pound sign. That's £240 as a final answer. Okay, so in a box of cereal, 40% of the weight is nuts. The rest of the cereal is corn. Write the ratio of the weight of nuts to the weight of corn and give your answer in the form 1 to n. Now if we start by writing the ratio to start with, we've got nuts to corn, and that is 40%, and the other percent would be 60%. So that must mean we get our ratio as 40 to 60. Now this isn't too bad. To get this in the form 1 to n, then we just need to look at the number on the left and think, what do we divide that by to get it to 1? And the answer is always just to divide it by itself. So we're going to divide it by 40. And when we're simplifying a ratio, we're going to do the same to both sides. So we're going to divide the other side by 40 as well. So we already know that's going to make 40 become 1. And for the 60, you can just type that in on your calculator. So 60 divided by 40, and it comes out as 1.5. Or of course you could write that in a fractional form, you could write it as 3 over 2, but that comes out as 1 to 1.5, and that would be our final answer, and that's how you go about writing ratios in the form 1 to n. Our whole process here is to get the cost of 1, and in this particular question it says that 8 identical pencil cases cost £12, and we want to work out the cost of 10. So this time we are going to get the cost of 1 pencil case, but this time we have 8. So we need to actually do £12, the amount divided by 8, and that is going to leave us with a decimal. So for this one here, we just need to be careful when we do our division, because we're doing 8s into 12. Now hopefully you can already spot that that's not going to fit in perfectly, so I'm going to add some decimal places afterwards as well. So 8 fits into 12 once with a remainder of 4. So carrying the decimal up, 8 fits into 45 times, and because this is money, I'll add the 0 on at the end as well, because that's worked out that one pencil case is equal to £1.50. So if I put 1, and I'll put PC for pencil case, and that is equal to £1.50, and this question here wants us to work out the cost of 10. So to get the cost of 10, we would multiply both of these by 10, and that would give us our total cost. So for 10 pencil cases, and again this is quite a nice one, because multiplying by 10 we can just hop the decimal over the 5, so it becomes 15.00. And obviously writing that in terms of money, that is a cost of £15. So that is how we're going to go about answering these questions. Okay, so for this question it says a train travelled from Manchester to London. Train A left Manchester at 8:35 and arrived at 11:05. So train A, 8:35 and arrived at 11:05. The train travelled at an average speed of 110 miles per hour. It says train B also left Manchester at 8:35 but was diverted by an extra 37 miles. So just highlight this one, train B also left at 8:35, diverted by an extra 37 miles, and it got to London at 11:35. Work out the difference between the average speed of train A and train B. Okay, so for this one here we actually have two separate journeys. We have train A, which is going to leave Manchester to London, and there we go. If we just label that up, and we'll put the times in as well so we can work this out. So Manchester to London, it leaves at 8:35 and it gets there at 11:05. Again, you don't necessarily have to draw these diagrams, but just to help us to visualise it. We have train B, and that is going to leave Manchester to London, the same journey. It leaves as well at 8:35, but this train arrives at 11:35, so half an hour later than train A. And there we go. So for each one of these journeys, we're going to have a look at a speed, a distance, and a time. And of course, this question wants to work out the difference between the average speeds, so we may or may not already have a speed for one of them or both of them. Of course, if we already had the speed for both of them, we could work it out straight away, so we're definitely not going to have both of them. So for this first one, train A, it leaves at 8:35 and arrives at 11:05. So that is a time of 2.5 hours. So if we keep that in hours, that would be 2.5 hours. For the next part of that, it also says it goes at an average speed of 110. So it goes at an average speed of 110, that's in miles per hour. So straight away we're going to be able to work out a distance. Let's have a look at the second part of the journey though. This one leaves at, or the second train, this one leaves at 8:35 and gets there at 11:35. So that is a time of 3 hours. So that's going to be 3 hours, again just half an hour longer, but it is diverted by an extra 37 miles. So we'll be able to add 37 onto the distance once we know the distance of the journey. So we just need to remember that, so I'm going to underline that because we're going to start with train A. Now again, just remembering your formula for this, so every question always write it down. We're going to look at speed, distance and time. And there we go. So for the first one, we're working out a distance, so that is going to be speed times time. So we need to work out 110 times 2.5. Now again, in order to work that out, you can just do your working out to the side. So if we take the decimal out, that would be 110. We'd multiply it by 25. So 5 times 0, 5 times 1, 5 times 1. Placeholder, 2 times 0, 2 times 1, 2 times 1, and add it all together. So that'd be 0, 5, 7, 2. Hop your decimal back in. So we're hopping it back in once, so that comes out as 275. So there we go, that is a distance of 275 miles. Again, I'm going to write miles this time because I've accidentally said meters on the question before, so we don't want to get confused between miles and meters for this. So for this one here, we'll get rid of that working out. Obviously you want to leave all your working out, but just to show you there, you can always do your working out to the side. Of course, multiplying by 2.5, you could just double it and add on a half as well, if you know some little tricks with your multiplication, but if not, just do your multiplication to the side. So that 275 miles is going to be the same as the distance over here. But of course we have the extra 37. So we need to do 275 plus the additional 37 miles that train B was diverted, and that gives us 2, 12, 7, 10, that's 11, carry the 1, 312. So this one over here has had to go 312 miles. And there we go. Now we can go about working out the speed for this journey. So for this one here, to get speed, we're going to do distance divided by time. So we need to do 312 divided by 3. And again, we can just do that to the side using some working out. So 312 divided by 3. 3 goes into 3 once, doesn't go into 1. Carry the 1, it goes into 12 4 times. So the speed over here is 104. And again, that's in miles per hour. So there we go, we have our two speeds. We had 110 from the question, 104 from what we've just worked out, and it wants us to work out the difference in the speeds. So in order to get the difference, our last little bit of working out, and you can do this in your head, but obviously we'll show our working out for this, it would be 110, take away 104, and when we do that, you just get the answer 6, and that is 6 miles per hour. And there we go, that's our final answer, and that is the difference between their speeds. Okay, so this question says Harry travels from A to B at an average speed of 50, and then he travels from B to C at an average speed of 70. Harry takes a total of 5 hours to travel from A to C, and the distance from B to C is 210. Calculate Harry's average speed. Right, so let's have a look at this one then. So we've got A to B, and we've got B to C, and then we've got the total overall journey there. There we are. And thinking about what we've got a speed, distance and a time, and we'll see what happens in this question. So in this question here, let's have a look. We've got an average speed of 50 for the first one, an average speed of 70 for the next one, and then we've got a total time of 5 hours from A to C. So this time we've been given our total. Look, we've got 5 hours as our total, and we've got the distance from B to C, which is 210. There we go, so 210. Right, so let's have a look at how we can now go about working this one out then. So ultimately we are looking for the average speed for the total journey. So we're looking for this one here, but we're missing quite a lot of pieces. Now what we can do is we can start to work backwards. So if we have a look at this first section here, this second journey from B to C, from Brockley to Cantham, if we can go about working that out, we can get this time down below, and we can definitely do that. Speed is distance over time. So time down the bottom for this first little box that we can work out here is distance divided by speed. So 210 divided by the speed, which is 70, and that gives us 3 hours for that part of the journey. Now we can work backwards because we know that these two journeys have to add together to make 5. So the other part of the journey, if we do 5 take away 3, tells us that this first part of the journey must have been 2 hours. And now we've got that, we can work out the distance of that journey. Distance is speed times time. So this one here, speed is 50 and the time is 2, so that must have been 100 miles. There we go, and now we can get our total distance for that journey there. So we've got 100 plus 210, and that equals 310. And now we can just finish it off like a normal question. So it's not particularly any more difficult than the previous questions. It's just actually working backwards to go back to that first part of the journey so that we could get the overall distance for this total journey here. So now we can do our normal sum. We've got distance divided by time. So we've got 310, the total distance, divided by the 5 hours, and 310 divided by 5 is 62 miles per hour. There we go. And also thinking about the logic here, that is in between 50 and 70, so our answer makes sense. And you should always be thinking about that. Does my answer make sense? Is it somewhere in the middle of the two? Okay, so this question here, we've got simplify, and then we've got some x's and some y's. So that word simplify just means let's make this shorter, basically. We're going to collect together all the x's, collect together all the y's, or whatever pieces we have, and we're going to write this in a shorter way that's easier to see. So it's up to you what method you choose. I'd just like to look at the expression here and just have a look at what x pieces we've got. So we've got a 3x there, and we've got a plus 4x. Now I'm going to emphasise the plus and the minus every time because that is important, that it's a plus 4x and not a minus 4x. So we've got 3x, and we're going to add to that 4x. And 3x and 4x added together gives us 7x. So we've got 7x's in total. Then I'm going to look at the other numbers, or the other pieces, separately. So we've got a 5x, and we've got a 5y and a negative 2y. So 5y minus 2y, let's have a look. What does that come down to make? 5 minus 2 is 3, so that is positive 3y. So we've got 3y's and it's positive 3y, So I'll just put a plus there just to emphasise that that's positive. We've got 7x's, add 3y's, and that's that simplified. X's and y's can't join together, they're separate pieces. So 7x add 3y is our final answer. Okay, so this one here, we've got it a little bit jumbled up. It's a little bit different to the last few, but let's just follow the exact same process and see what we get. So first bracket, 4 times the x gives us 4x, and 4 times the negative 3 gives us negative 12. Now moving on to the next bracket, but again, just being careful because we've got a negative 2 at the start. So this time it's negative 2 times the number first this time. So negative 2 times 1 is technically negative 2, so take away 2. And then we've got negative 2 multiplied by negative x. So the negatives are going to become positives because we've got a negative multiplied by another negative. So we've definitely got positive. And that's 2 times the x, so plus 2x. Negative 2 times negative x is positive 2x. And again, just tidying this up just like before, so 4x and the other x is at the end this time, so 4x plus 2x is 6x, and negative 12 take away 2 is negative 14, so 6x minus 14. Again, just be very, very careful with whether the number is negative or not. Obviously this was a negative 2, particularly careful when you times it by this negative x there to make sure you get your symbols right. Okay, so something slightly different here. We've got 6x plus x squared. Now we're going to think what do both these pieces divide by? So we've got a 6x and we've got a 1x squared. Now, number-wise, the only thing they both divide by is 1. So obviously dividing by 1 doesn't change anything, so we don't need to think about dividing by 1, but they also both have an x in. So we could divide them both by the letter x. And we've just got to think, okay, well, what's going to go inside my bracket then? So what do we times x by to get to 6x? And that's going to have to be 6. X times 6 is 6x. Copy the symbol again, plus, and what do we times x by to get to x squared? Now remembering x squared just means x multiplied by x, or x times x, so it's got to be another x, and x times x gives you x squared, and that's that factorised. So no number on the outside, but we get a letter on the outside, and again if we expand it out, x times 6 is 6x, and x times x is x squared, and again just copying the symbol there with a plus, and it matches. Let's have a look at one more. So this question says factorise fully, and that normally means because there's 2 factors that can come out. So let's have a look. We've got 12x squared and we've got 10x. Now straight away they've both got an x in and they've both got a number. So let's just look at the numbers to start with. So numbers that go into 12 and 10, our only option there is 2. So we can definitely take a 2 out. But there's an x in both as well, so we can also take an x out. Okay, we're just having a look at what goes into both. 2 goes into both those numbers and x goes into both the letter parts. So 2x on the outside, open the bracket. Now what do we multiply 2x by to get to 12x squared? Well, from 2 to 12 we have to times it by 6, and to make sure we get the x squared as well, we've also got to put an x in there. Again, just copy the sign, we finish with that piece. How do we get from 2x to 10x? Well, from 2 to 10 is 5. So times that by 5, but we don't want to put an x in with that piece because we don't want an x squared up here, just the 10x. So that's that one finished. There we go, 2x brackets 6x minus 5. Okay, so we've got some squares going on in this. We've got work out the value of 2x squared and then take away y. So this is where the brackets really come into their own, because when we sub this negative 3, and in particular if you're using a calculator, it's very important that you put them in a bracket. So we've got 2 lots of, and then we've got negative 3 squared. Take away y. Oh, sorry, and y is given to us, isn't it? It's 10, so take away 10. Okay, so the first thing that I'd want to do is work out what this value of the bracket is. So it's negative 3 squared, which means negative 3 multiplied by negative 3. And a negative times a negative makes it positive, so the answer's 9. So actually what we've got in the bracket there is 9. Okay, so once we square that, it becomes 9. So we can rewrite this, we've got 2 lots of 9, take away 10. There you go. And if you check that on the calculator, if you type in negative 3 squared on the calculator, it will give you the answer negative 9, and actually the answer is positive 9, and that's where you've got to make sure you put the brackets in, because the calculator will then understand that it's a negative number and it doesn't want you to just square the 3 and then stick a negative next to it. Okay, so you can always try that out on your calculator, but it will only give you this value of positive 9, which we know the answer is if it's in a bracket there. So 2 lots of 9 take away 10 is 18 take away 10. And 18 take away 10 just gives us the answer 8. So be very, very careful when you're doing these. Make sure that you just write it out very carefully. And remembering it's 2 lots of here, 2 times that value of negative 3 squared, which is 9. So it's 2 lots of 9. So the next ones, I've got 2 examples here. both with fractions involved, both with similar numbers. We're going to see how we treat them differently. So this one on the left here, y equals x over 4, take away 8. Now that x is locked in by that divide by 4 at the moment, and whenever we've got these fractions in, it's locked in, but that minus 8 is free for us to move, it's outside of the fraction. So we can get rid of the 8 and then just focus on the fraction to start with. So I can add 8 to both sides as it's a minus 8, so add 8, and we get y plus 8 equals x over 4. Now the only thing we've got left is the fraction, and we can times both sides by 4 to reverse that divide by 4. So the second step here would be to times by 4, just to reverse that divide. And if we times this side by 4, we can open up a bracket and just say, okay, well, it's 4 lots of y plus 8 equals x. And if you wanted to, you could actually expand that bracket. So we could write our final answer as x equals, and we could expand the bracket, 4y plus 32. Okay, you don't actually have to expand the bracket. We could leave it in a bracket, but it's fine to expand it as well. To be fair, we could actually take a different approach here. We could have times by 4 to start with, but if we did, we'd have to remember everything gets times by 4. So we'd just have to remember to times this 8 by 4 as well, and we'd have got negative 32 and then added it over. So there are other ways of approaching it, but it's like that's just the way that I prefer to do it. But there are two ways of actually rearranging that from the first step. Onto this one on the right. Slightly different. There is only one step for us to start with because everything on the top here is locked in by this divide by 4. So I'm going to have to times by 4 to start with this time because everything is locked in. So timesing by 4 would leave us with 4y on the other side. So we'd have 4y equals x minus 8. And then I would be able to add the 8 over. So I'm actually forced into doing it that way on this particular question. When we add 8 over, we get 4y plus 8 equals x, and again you can rewrite that if you want, x equals 4y plus 8. Okay, so quite a few different questions there on rearranging. Make sure you've made some notes on them. Just remember everything you do, just reversing what is happening to x. So if that means reading it out, so if we look at this one here, okay, you could read this question as y is x take away 8 and then divide by 4. So the last thing we did was divide by 4, so the first thing we do is reverse that and then add the 8. We've got some square roots introduced in this one. Now when we've got a square root here, everything underneath it is completely locked until we get rid of this square root. Now the opposite, the way to get rid of a square root is just to square both sides. So if we square both sides, we'll get y squared on the left, and squaring the right hand side literally just removes that square root, so nothing's going to change underneath it. We just have 3x plus 4. So once we've done that, quite nice and easy, it looks quite similar to some of the others. We're going to minus 4 from both sides, and we get y squared minus 4 equals 3x, and then finishing it off just like some of the first ones we did, we're going to divide by 3. So divide by 3, and we get y squared minus 4 all over 3 equals x, or we could just write the x equals at the start. So x equals y squared minus 4 over 3, and that's our final answer there. Just remember that when we've got the square root, everything's locked in until we square both sides. So 2x plus 9 equals 16. Now taking the same approach here, we'll take away the 9, so minus 9, and we get 2x equals, take away 9 from 16, leaves you with 7. Okay, so the first thing you might be noticing here is, oh well, hold on, 7 doesn't divide by 2. Well, it does, it's just not going to give us a whole number. So we'll take the same approach again, we'll divide by 2 because we've got 2 times x here, so divide by 2, and we get x equals 7 over 2, and that's fine just to leave that as a fraction. Now obviously when it does simplify down, I would advise you go for it. Okay, 2 goes into 7 3 times, so we have 3 and 1/2 left over, or you could write your answer as a decimal, you could write 3.5, but it's perfectly fine for you to just leave your answer as a fraction and then write it as a mixed number, or simplify it in any way that you think is appropriate for that type of question. Okay, so just obviously be thinking about that. If it's not a whole number there, that's absolutely fine, just write it as a fraction. So the first one here is 6x plus 5 equals 2x plus 15. Now the only way we can solve this is when we've only got x's on one side, or unknowns on one side of the equation. Now at the moment we've got a 6x here and a 2x here. Now we can subtract an amount of x's from either side of the equation, so we could take away 2x's or 6x's from both sides to eliminate one of them, but I always just go for the smallest one. Okay, it's just going to avoid having any negatives, so I look for which is the smallest value of x here, and we can just get rid of that from both sides. So I'm going to subtract 2x on both sides of the equation, And once we've done that, you'll hopefully see that this looks a lot nicer. So take away the 2x when we have 4x plus 5, and that now equals positive 15 over there. So I'll just leave that as 15. And now we've got quite a nice simple equation. We can just follow our normal steps. We can take away the 5, and then we're going to divide by 4, but let's have a look. Take away the 5, we get 4x equals 10, and then dividing by 4, and again 4 is not going to go into 10 perfectly, so we'll write it as a fraction. Divide it by 4, and we get x equals 10 over 4, which we can then simplify if we want. So simplifying that, we can divide top and bottom by 2, and we get 5 over 2, which we could also write as 2.5, or 2 goes into 5 twice with the remainder 1, 2.5. Okay, so lots of steps there. The first thing you need to do is obviously just to get the x's on one side of the equation. When it came to this one, the easiest way to do that was just to subtract 2x from both sides, but ultimately we just want to get the x's on one side, isolate the x's on their own, and then get all the numbers onto the other side. Okay, so this question says work out the value of x, and what we've got here is we've got some algebraic angles. So we have 2x, x plus 18, and 2x plus 7. Now this is going to be very similar to one of the first questions we looked at in terms of we're going to make a linear equation here with x on one side, but it doesn't explicitly give us a number to set our expression equal to. So this is going to be testing your angle facts and just knowing that angles in a triangle add to 180 degrees. And we know that these three angles here have to equal 180. And that's what's going to be involved in some of these angle questions here, testing that obviously that knowledge fact there of what these angles add up to. So if we add these all together, we can set that equal to 180. So again, if we count up the x's, we've got 2 there, another one there, that's 3, and then 2 more there, so that's 5x in total. So we have 5x, and if we add up the numbers there, we've got 18 and a 7, and 18 adds 7 is 25, so we have 5x plus 25, and that is going to be equal to 180 degrees. So there we go. We started off by creating our expression for the angles, or the sum of the angles within the triangle, and then we finished it off by setting it equal to the 180 degrees using that knowledge fact that we already know. So solving this then, we can take away the 25 from both sides, and I haven't really been doing this on some of the previous questions, but it's always good just to show that little bit of working out there, what you're actually doing. So take away 25 from both sides, and 180 take away 25 is 155. So we have 5x is equal to 155. And then to finish that off there, we just need to divide by 5. There we go, and 155 divided by 5 is 31. Now obviously if you have a calculator, little bits like that are nice and easy to do, but if you don't forget that you obviously can just do a little bit of bus stop to the side. You can always do your working out to the side there just to work those little bits out. So there we go, x is 31, this is in degrees, so x is 31 degrees, and there's our final answer to finish off this question. Okay, so there are a few different types of triangles that we can obviously look at. There's a scalene triangle where all of the angles are different, like the last one that we looked at. There is an equilateral triangle, and an equilateral triangle would be drawn like this, and there'd be a little dash on all of the sides like that, and all of the angles in an equilateral are 60 degrees. So it doesn't make for a very interesting question because every question is the same, but this particular triangle here, we only have 2 of those dashes, and that tells us that it's an isosceles triangle. And an isosceles triangle, the base angles are equal, but the base angles are 2 particular ones. Now I have this triangle oriented in a flat, or sitting on its base at the moment. So for this one here, the base angles are just the 2 that are sitting on the base. But we could rotate this triangle in any orientation. We could rotate it around and instead have it sitting on this line here, and in which case those 2 would not be the base angles of an isosceles. So to find the base angles of an isosceles, you look at the 2 angles that are below, and it's almost like you can think of them as little eyebrows, and underneath them are the eyes. And underneath where the eyes are the 2 angles that are the same. So for this one here, if 23 is one of the base angles, then over here, underneath the other, what I call an eyebrow, is also a 23 degree angle. So this one here would be 23 as well. And the reason behind that is because base angles in an isosceles are equal. So now we've got those 2 base angles, we can figure out what's left for the top angle using our fact that angles in a triangle add up to 180. So if we add together what we have, 23 and 23, that adds up to 46. So to find the missing angle, we would do 180, take away the 46, and that leaves us with 134. and that is 134 degrees, and always just check that that adds up to 180 still. So we had 46 for the other two, plus the 134, that adds up to 180, so x is equal to 134 degrees. Okay, so we're not going to look at special quadrilaterals, we're just going to look at quadrilaterals. So a quadrilateral has four sides, and the rule for a quadrilateral is that they all add up to 360 degrees. And again, I'm just going to draw like a rectangle sort of shape there, just to show that our rule that we're going to be using. So if all of the angles add up to 360 degrees, we're going to treat this just like our triangles, and that is to add up what we have first and then figure out what's missing. So at the moment we've got these three angles, 120, 140 and 58. And if we add those all together, 120, 140 and 58 degrees, and add them all up, let's see what we get. So 8, 11 and 3, so 318. So our missing angle there is whatever the difference is between 318 and 360. And we can do that by obviously just working it out. We can do 360, take away the 318, and just work that out. Obviously, if you have a calculator, nice and easy, we can work it out, but we're going to have to borrow for this. So 8 from 10 is 2, 1 from 5 is 4, and 3 from 3 is 0. So that comes out as 42 degrees, and that would be our final answer. Okay, so we have a triangular prism here. Now again, we're just going to identify the cross section, and in this case, the cross section is that triangle that we can see sitting on the front just there, and it's a right angled triangle, so we should be able to work out the area of that nice and easily. Now obviously not forgetting your formula for the area of a triangle, that is half base times height, or you can do base times height and divide your answer by 2. Up to you how you do it, but we need to identify the pieces that we're going to have a look at here. Now for the triangle, we have been given a length here that we don't actually really need, and that's this length just here, the length of the hypotenuse of that right angled triangle. Now in order to work out the area of that triangle, we don't actually need that length there because it's the slanted length. We want the height being the perpendicular length to the base. So if we take 15 as the base and 8 as the height, then we can just use those two lengths. We don't actually need that 17 at all to work out the area of the triangle. So working out the area of the cross section for this one, we'll do 8 times 15, and then we're going to halve our answer. So 8 times 15 is 120, and half of that, so 120 divided by 2, gives us an area of 60. So the area of the cross section in this case is 60. The rest of the process is pretty much exactly the same. All we're going to do is multiply that by the depth that that cross section goes through the shape, which again in this case is 10 centimetres. So we can take our 60, multiply it by the 10 centimetres, and it gives us a volume in this case of 600, and again it's centimetres, so centimetre cubed, and there's our volume for a triangular prism. So as you can see, once we've learnt obviously working out the volume just by finding the cross section, it relays very nicely into any prism here, and you can see it's pretty much exactly the same here with our triangular prism. All you need to do is you need to just make sure obviously you're clued up on all your area formulas. So in this case, half base times height or base times height and divided by 2, whichever one you prefer there. But there we go, that's how we work out the volume of a triangular prism. Okay, so when it comes to a triangular prism, obviously we also have a triangular face now. So we've not just got rectangles involved, we're also going to have to look at these triangles. So if we label up the faces that we have one triangle at the front, and we also have another triangle at the back. So that is going to be number 1, and that is the same face on the front and the back. We also have this slanted length, which is going downwards. It's kind of difficult to label them, obviously because we have a see-through shape here. So we've got number 2, which is the front rectangle there, sloping downwards. We also have the one on the back, which is another rectangle, and we'll call that face number 3. And we actually have one more, and let's label that with another colour, and that is the one on the bottom, and that is face number 4. So 1 and 1, they have 2 triangles, and then we have rectangle 2, rectangle 3 and rectangle 4. Again, you can work these out in any order, but just so we can actually see them. So for number 1, for the triangle, let's work that out. So to work out the area of a triangle, you have to do base times height divided by 2. So that is going to be 6 times 8, and then divide our answer by 2, or of course you could halve the base and then times it by 8. So that comes out as an answer of 24. Now, not forgetting, we also have 2 of those, so if we do 2 times 24 straight away to take into account that we have our 2 triangles, that's going to give us an area of 48 for our triangles. We can then move on to one of the rectangles, so let's go with number 2, and let's just get the side lengths. So for that particular rectangle, we have 10 going down the slanted length there, and we have 9 down the bottom. So to work out the area of that, we would do 9 times 10, and that gives us an area of 90. So now we've got our area of 90, let's write that down as well, and that one's finished. Now we can move on to our next rectangle, and that is the rectangle on the back. The rectangle on the back has a bottom length of 9, as you can see already highlighted, and it has a height of 8. So for that one there, we would do 8 times 9, which gives us an area for that one of 72. So now we've got that one as well, we can label that. So number 3 is 72, and that's another area done. And then moving on to our last one, we have the length along the bottom. Again, that uses the length of 9, and it has a width of 6. So for that one there, we can label this one, and we can do 6 times 9. There we go, which comes out as 54. And that is our final area. So for number 4 there, we have an area of 54. Right, so we've got all of our areas. All we need to do is add them together. So if we put them all together, we have 48, we have 90, we have 72, and we have 54. And we just need to add them all up. Be very careful when you do this. So that adds up to 14. And then we've got 13, 25, 26. So that comes out as 264. So my final answer would be 264 centimetres squared. And that would be the surface area of this triangular prism. So obviously just a little bit more to think about there, because we had the triangular face, and then we also had 3 different rectangles for this particular prism. It says work out the size of angle X, and you must give reasons for your answer. Now this bit's really important. It says you must give reasons for your answer. Now some of the time I'm going to write down my reasons. Okay, when you are doing these questions, you always need to write the reasons down, but I'm going to try and minimize the amount of writing that I do, just to save a little bit of time as we're going through this. Okay, and I'll just speak about them instead. But we will write them down initially and start thinking about maybe a little shortcut that I can write down, just so that you know when and where we're going to write down those reasons. So having a look at this question, then we've got these parallel lines, okay, and the parallel lines are indicated via these little arrows here. Now when you have a line that is going through those parallel lines, so from B down to E, this one here, there are lots of rules and angle rules around about these angles. I'm going to extend that a little bit further because it does go all the way through there. Okay, so obviously in this question we've been given the angle of 47 down there, and it wants us to get all the way up to that angle of X. And to be honest, there's probably about 5 or 6 different ways of actually getting there, but when it comes to a question like this, you have to almost ignore what we're actually looking for, and we're just going to find everything. Okay, we're going to have a look at working out every single angle around all these points here. Now when it comes to obviously the parallel line rules, there's a few that we need to know, okay, and that's how we're going to jump from one line up to the other. And what I mean by that is that's how we're going to get from down here on this line, and we're going to jump up to this line here. Okay, so those little rules that we're going to have a look at. The first of them, and there's 2 different ways of writing this, but the first of them, and you hopefully recognize this, it makes this Z shape, okay, and those are called alternate angles. Okay, so if we make this little Z shape here, okay, that's going to be an alternate angle, and our reason there is that alternate angles are equal. And there we go, alternate angles are equal. There we are. And throughout this video, obviously, if we ever use an alternate angle, that's the exact reason that we have to give. We have to say that alternate angles are equal. That is a reason, okay? We don't just state that it's an alternate angle. We actually give that as a reason and say exactly what that means and in terms of how we get in there. So that angle there hooks particular angles in it, hooks these 2 either side, and those 2 angles are equal. But of course, you could have that angle going along the other side as well. Okay, we could make what kind of looks like a backwards Z. I could make a little Z going this way as well. And that hooks in this angle here, X, and this angle down here. And as you might be able to already see, that's going to give us part way or a little bit of a hint towards how we're going to get to that final answer there. But okay, let's get rid of that, because there are other angles as well that we might have throughout these questions. And one of them is when it creates this F shape. Okay, and these angles here, I'm going to draw this out. So a little F shape, and they are called, and it hooks in this one and this one underneath the F that time, and they're called corresponding angles. And the reason again is that corresponding angles are equal. Okay, there we are. Corresponding angles are equal. Okay, that's another reason that we might have throughout this. So as you can see, if that's 47, this is also going to be 47 up here. Okay, but just thinking about different ways that we can get there. So that's two different rules, and you might have already spotted we could use either of those to actually get our final answer up there. But again, before we move on, there is one more angle rule that we might have to use throughout this video, and that is when it forms this little C shape here. And angles within that, again the ones that they hook in there, these ones here, they add up to 180, okay, and they are called co-interior angles. There we go, so I'm just going to draw this as a little C, and co-interior angles add up to 180. There we go, so co-interior angles equal 180 degrees, or add up to 180 degrees. Okay, so obviously those are the three angles that you need to make sure that you've got, or the three angle rules that you need to make sure that you've got written down throughout this video, because we're going to be using at least one of these in every single question throughout the video, so you need to know these pretty well and sort of recognize how to spot them. But essentially you are always looking for a line that jumps or moves from one parallel line to another, and in the case of this one on the screen here, it goes from B to E, and it does extend down to G, but that's our line that's going through the parallel lines there. Okay, so we're going to have a look at actually going about answering this. So we're going to see how we can actually get to an answer, but let's have a look and see which one of these angle rules we might be able to use. Now, there are lots of different ways of going about this, okay? In fact, we could go, and we'll talk about three different ways. Okay, so I'll start with one way. One way we could do is we could get this angle here, then say that that's 47. So not one of the rules that I've talked about, but when we get this little X shape going along here, two lines crossing over, it creates these two angles here. And this angle here is vertically opposite to the other angle there. So I would say that that angle there is 47 because vertically opposite angles are equal. There we are. And you don't just say opposite angles, you do say vertically opposite angles are equal. There we go. Are equal. Right, there we go. So vertically opposite angles are equal. That's my first reason there. And then I could move on to another angle, okay, and I could actually spot one of my parallel line rules. Now I could either from there get my Z shape, and that would give me this angle up here, and that would be alternate. Okay, I could say that that's 47, okay, because alternate angles are equal. There we go, alternate angles are equal. And then from there, I could do angles on a straight line, okay? Again, let me just get rid of this Z shape. There we go, we've got angles on a straight line, so next to that X there, these two angles have to add up to 180. So I would simply do 180 and take away 47. So 180, take away 47, and that would give me 133. There we go, that'd be 133 degrees as my final answer. Okay, and showing that there, 180 minus the 47, and obviously just always showing you working out there. So my final reason, because it does say you must give reasons for your answer, I would say angles on a straight line equal 180. Now I'm not going to write that down again, I'm going to stop writing some of these down because it's going to make this video about twice as long if I have to keep stopping and writing them all down, so I will just speak them instead. But there we go, that's one way of getting there. There are other ways as well. I could have maybe not found this alternate angle. I could have then had a look at this as the co-interior angles look. I could do 47 with that one, makes that backward C shape, and those two angles have to add up to 180. So obviously I'd do 180 take 47. Again, that would get me straight to the 133. But again, there are lots of different ways that I could get there. I could have even done angles on a straight line here. I could have done next to the 47 is 133 and got that one first. And then we could have done, I'll swap to the same colour as the picture over there. There we go. I could have done my F angle shape there, which is a corresponding angle. So I could have done corresponding angles are equal as well. And I could have done any little combination of those on different sides of the line, but essentially there you just got to find your way of getting there, okay, and make sure that you label and describe whatever reasons you are using, okay. That's what's important, in that whatever way you do it, you need to obviously give the reasons for those. So the particular way that I did it, and I did it on the first one, I did vertically opposite angles are equal, then I did alternate angles are equal for this one, and then I did angles on a straight line equaling 180 for my final one there. But there we go, there's some of the rules. Obviously you need to just make sure that you've had a practice on some of those. Right, okay, so when we start looking at these types of questions, there would be some more information with this. Now I have extracted the information away from the question just so that we can focus on the mathematics behind it, but there'd probably be quite a lot of information here. So looking at the diagram for a start, it would probably say something along the lines of C to F being a straight line, okay, just telling us that obviously we can apply straight line rules at these angles, we can apply straight line rules at these angles. But obviously I've taken the information out there, so we are going to just be assuming that these lines are straight lines for the majority of these questions, just so that we can focus on the maths here. But you would have some of that extra information. It is also quite likely that you would be told that this line here, A to E, and this line here, D to E, are the same length, or that they're equal to each other, okay? But as this is given to us on the diagram, indicated via these lines here, okay, we know that they're the same length anyway, so we're not going to worry too much about some of the language that would be behind these, more just practicing the methods and the process. But just so you know, there would be quite a lot more information with this. Now let's have a look at this question then. Now straight away, these little lines, they tell us that this is a particular type of triangle. If two lines are the same length in a triangle, that means it's an isosceles. Now with an isosceles triangle, the angles underneath it, so underneath those little dots here and here, they are equal. So at any point, if we can find one of those angles, we'll be able to find the other one, because we know that they're going to be the same, as it's an isosceles triangle. Again, the reasoning there is that angles in an isosceles, the base angles are the same in an isosceles. So let's have a look and see if we can get there. I'm not going to focus on those angles straight away. I just want to see what can I find, if I can find any just yet. Now we've been given the angle of 38 up here. So 38's up there. Here's our parallel line, and here's our other parallel line. So straight away we can jump between the two. Okay, so we can actually take this going down here, and then jumping across. And there we go, that's an alternate angle just down here that it's been hooked in by, and that is 38 degrees. There we go. So again, alternate angles are equal. I'm just going to write alternate equal. There we go. That's a bit shorter, that's a bit better than drawing one of those Z's. So alternate angles are equal. Now we can go about having a look at these angles in the triangle, because we've got one angle in the triangle, and as it's an isosceles, I can find out what's left to split between the two base angles, as we know that these two are the same. So if I take away 38 from 180, so 38 from 180, and let's write that down, 180 minus 38 leaves us with 142. There we go. And as those two base angles are the same, there we go, we can split that in half, so divide it by 2, and that gives us 71 for both of them. Now I haven't written down this reason yet, so I'm going to write this one down, and that is that base angles in an isosceles are equal. There we go, base angles in an isosceles are equal. There we are, and that's my reason for getting the 71 here. There we go, so they're both the same. Now we can finish this question off, because obviously this is a straight line, so just next to that 71 there we have two angles together, and they both have to add up to 180. So this one here I can find straight away. I can do 180, take away the 71, and that leaves me with 109 degrees as my final answer. And again, my reason there would be angles on a straight line, which I'm going to shorten down with my little picture again. So straight line equals 180. There we go. But there's my final answer, 109. And again, we had three reasons there. One was the alternate angles being equal for the 38. The second one, base angles in an isosceles are equal. And my final reasoning there was angles on a straight line equaling 180. Right, there we go. So that's how you're going to tackle some of these slightly harder problems. Now, this question says work out the bearing of B from A. Now, there's a few things that we need to discuss when it comes to bearings. For starters, there's three really important rules. When it comes to bearings, we always measure from north. Okay, so I'm just going to write these down to the side with the first one. So we measure from north. So north is just going to be our starting point for all of our bearings, okay, and that's going to be absolutely crucial. Obviously, we've got to have a place to start from, and north is obviously just quite an obvious one to go from when we're measuring a particular degree when it comes to directions and bearings. So that's our first rule. We've got to measure from north. The second one is the direction we measure in. We measure clockwise. Okay, so we always go clockwise. Okay, no particular reason why. It's just that we obviously have to pick one of them out, what clockwise or anti-clockwise. So it just seems obvious for us to go clockwise, really. And our third rule is that the bearing has to have 3 digits. Okay, so all bearings have got to have 3 digits. So that means something like 20 degrees. Okay, it would be written as 020 degrees, okay? So obviously it doesn't apply to any numbers that are already 3 digits, like 120 degrees would always be 120 as it already has those 3 digits. But if any numbers don't have 3 digits and we're given a bearing like that, we will use 3 digits. So there are 3 really important rules. We're going to measure from north clockwise, and we're going to use 3 digits and apply that to any numbers that aren't already 3 digits, okay? So this question says work out the bearing of B from A, and the language is always quite nasty. You know, you've got to get your head around it just to start with. Once you've got your head around it, it's fine, but it says work out the bearing of B from A. So you just have to look at that second bit really. Look, we're going from A. So if we imagine we're a little person, we're standing at A, there we go, we want to know how to get to B basically. So what's the bearing of B from A? Okay, and we could have a look, we'll have a look at all the different types of language as we go through this. But if we're standing at A and we want to get to B, bearing in mind that we're going to be facing north, that means to get to B, the bearing is going to be all the way around clockwise to this line here. Obviously B being down here at the bottom, so that line with the B at the end. So we've got to figure out all that direction going across now. Now this diagram's quite nice, look, because it's put this little dotted line going downwards, just to sort of show us this obviously straight line going south. Now that may or may not be there. Okay, but obviously this one is. So all we've got to have a look at really is how many degrees that is now. Facing north, to get to south, look, that is a full turn. So that's a full 180 degrees. So it'd be 180 degrees for us to turn just to be facing south. Then there's this additional 40 degrees. So all we need to do is add those two together. So we have 180, add 40, and that will give us a combined total there for our bearing of, let's have a look, 220. There we go. So our combined bearing there for those two little parts to get to B from A is 220 degrees. Okay. Right, okay, so this question doesn't have a diagram. Now it says C is a town and it says the bearing of C from A is 50 degrees. Find the bearing of A from C, so going back in the other direction. So if we want to get to C and we're standing at A, let's sort of imagine a little diagram here. So we're standing at A, and we're trying to get to C, so this is A. Now obviously we need to measure from the north, so we're going to draw a north line in ourselves. There we go, and we're going to imagine just walking off in about a 50-degree angle, so it's by no means perfect, it's just a sketch, but there we go, that gets us off in a 50-degree angle. And we're not going to write 050 there, because it's just for the purpose of our diagram, and it gets us up to here, and now we're at C. And if I draw another north line in, there we go, and just imagine this is north. Right, let's move that down a little bit. Right, so the next step is to be thinking about what the question's actually asking now. So it's asking us to do, it says find the bearing of A from C. So now we're at C and we want to know, well, how do we get back to A? Now there's a couple of different ways that we could think about doing this. So I'm going to talk about 2 different ways, and it's up to you which one you prefer. I'm just going to discuss these 2 different ways. Now, one of the ways that I like to do this question is I like to think, okay, well if I just kept walking from A to C and I kept on going, look, let's just imagine we extend this line. So the line's going to be extended. Now this angle here, okay, is actually corresponding with the 50 degrees down there, okay, thinking about your parallel line rules, because these 2 north lines are parallel. Okay, so it creates that F shape, it creates that corresponding angle. So actually corresponding angles are equal, so we can say that this is also 50 degrees right here. Okay, so now we know that to get from C to the same direction we were going in before, it'd be an extra 50, and then we'd have to turn round a complete 180 degree turn, and that would be an extra 180, and then we could add those together to get the full bearing there, going clockwise from north, from C back to A. So if we add those two together, look, we'd get 180 plus the 50, and that would leave us with 230 degrees for our bearing going back the other way. Now that's one way of doing it. Now there's another way that you can think about it as well, so I'll talk about that one as well, and I'll probably use sort of both of these methods as we go through, but we'll have a look, and I think I'll just decide in the moment which one I'm going to use at the time. So the other way we could do it, so let's have a think about this. Now we're talking about parallel lines, so if you think about this as well, if these two are parallel lines, what we've actually got is a co-interior angle there, okay? These angles form that C shape, and we've got a way of working out that one there. Now these co-interior angles, they add up to 180, okay? So if these two angles add up to 180, we can work out the size of that. Look, I can do 180, take away 50, there we go, and that would leave me with 130 degrees for this angle here. Now if that angle there is 130, we already know that to get back to A from C, we have to go the remaining angle all the way around here, and those two there have to add up to 360, so I could do 360, and I could take away that 130, and that would leave me with 230 degrees. There we go. So both give us the same answer, obviously. Both are correct, both are good ways of doing it, but I think it's important that you know both of these, because particularly this co-interior angle method, that is used as you progress this topic onto some of the harder questions, okay? So you might need one or the other. Sometimes you can get away with just extending the line, sometimes you're going to need this one, okay? But it's important to know the both there, because obviously we're thinking about parallel line rules as well. Okay then, so looking at our triangle. Now again, let's think about how this relates to a rectangle. Because when we are looking at a triangle, and a right angled triangle is a very good one for this, if we were to turn this into a rectangle, which we could do by just drawing a cross and down, then that triangle there is actually half of the area of that rectangle. And that forms the basis of where our formula comes from. Because if the triangle is half of the rectangle, well, let's just take our rectangle formula and divide it by 2. And our rectangle formula is the length times the width, or you could call that the base times the height. So all we would have to do is we take the base, which we call b, we multiply it by the height, and then we divide it by 2. And there are different ways of writing this, but you could just write 1/2 of the base multiplied by the height, so you don't actually have to put the times sign, you just put half bh. So the area of a triangle is equal to half the base times the height. Now when we're doing that, you can do that in two different ways. You can multiply the base by a half, which halves the base, and times it by the height, or you can just do the base times the height and then divide your answer by 2. And that's what I'm going to do in this question. I'm going to take the base, which is 12, and I'm going to multiply it by the height, which is 5, and then I'm going to divide it by 2. And again in this question, for working out the area, we don't need to know this diagonal length, which obviously with a right angle triangle is called the hypotenuse. So if we don't need that length, we just need to focus on that perpendicular height, and that is a perpendicular height because, as you can see, we've got a right angle in our triangle, meaning that that is going to be a perpendicular line to the base. So all we need to do is 5 times 12, which gives us an answer of 60, and then we divide that answer by 2. So 60 divided by 2 gives us a final answer of 30, and again putting our units in centimetres squared. And there we go, we've got the area of our triangle. Okay, so looking at the area of a trapezium, and as with the other two, how does this relate to a rectangle? And you might have already spotted it's in a similar way to how our parallelogram did. And that is if we cut off this triangle at the end, and we were to rotate it and flip it around to the other side, and just slot it in just at the end there, we would end up having a rectangle. Obviously that's deleting this triangle off the end. So this is also related to a rectangle, but we need to think about how it relates, because by doing that I have taken away part of this 12 centimetres and I've added that part of that 12 centimetres onto my 8 centimetres. So what we're actually doing is we are reducing the length of the base and increasing the length of the top in this particular example. So we need to figure out what the length of that rectangle would be, and the way to do that is we look at both of those lengths and we find their average. So to find the average of two numbers, you add them together and divide it by 2. And that's what starts to form our formula. And when it comes to the formula of a trapezium, what we actually do is we take the top and the bottom, let's call that A and B, we add them together and divide it by 2. So A plus B divided by 2. And then we multiply that by the height, just like we do with a rectangle. So you multiply that by the height. Now again, there are two ways of writing this formula out. There is another way that we can use the fraction a half. So we could say it's a half of A plus B, and then we don't have to put that times sign. We could just get rid of the times sign and instead just put the letter H. So it's a half of A plus B multiplied by the height. So if we take that into account for this particular question, we're going to add together A plus B, and that is 8 plus 12. So 8 plus 12 is equal to 20. And take note of the fact here that we have to pick those two parallel lines as shown in the trapezium. If we were to add together the diagonal lines, well, they wouldn't be part of that rectangle that we made. So it has to be the two parallel lines, and that's what A and B are. So it's worth writing that down as part of your notes that these are the parallel lines. There we go, when we are working out the area of a trapezium. So we've added them together, we've got the answer 20. Now thinking back to our formula, we do need to make sure we divide that by 2. And that's what doing this half here also does, depending on which formula you prefer to look at.
So 20 divided by 2 gives us an average length of the rectangle of 10. So that 10 there is what we found when we cut off this part of the triangle and added it onto this part here. What we've actually found out here is what we would have done is to subtracted 2 from this length and added 2 onto the length just there. That would make the length go from 8 to 10 on the top and the length on the bottom go from 12 to 10. And that's what we have just found. So if we get rid of that, and then we need to just work it out. So we found that a plus b divided by 2 is 10, or the average length is 10, and then we just have to multiply it by the height, and you can see in this trapezium the height is 5. So to finish this off, we would do 10 times 5, and that gives us a final answer of 50 centimetres squared. And there we go, that is how we work out the area of a trapezium, and our answer is 50 centimetres squared. So very quickly running through that before you have a go, you do a plus b, which are the two parallel sides, you add them together, divide it by 2 to find the average length, and then multiply it by the height. Exactly the same as we would do for a rectangle. Okay, so this question here, there's two right-angled triangles, and it says work out the value of x, and if we just highlight that, x is down here, and again, giving your answer to 2 decimal places. Now, to start with, we can't find any of the lengths on this triangle down the bottom here, and if I just highlight that triangle, this one here, because we've only got the one missing length, we've just got the 4 there. So again, we must be able to get one of these lengths from the triangle above. And if you have a look at the triangle above, we can do that. We've got the hypotenuse opposite there, and we've got one of the shorter lengths as 5. So we've got the hypotenuse, so we can do 10 squared, take away 5 squared, and we can square root the answer. 100 take away 25 is 75. Now if we do the square root of 75, let's have a look what we get there. That is 8.66 and a few more decimals. I'm going to leave that as 8.66. Let's label that down here. So 8.66. Now, as I'm going to be using that number there, I'm going to leave that on my calculator because I want to make sure that I don't get any rounding errors here. But let's have a look at the second step. Now, leaving that number on my calculator, let's identify what we're looking for. This time we're looking for the hypotenuse, look opposite that right angle. We've got the 4, we've got the 8.66. So we just need to do 8.66, that number squared, which I'm going to do as my answer squared. So I'll do 8.66 with all those decimals in my calculator squared. I'm going to add it to 4 squared. And see what I get. So answer squared plus 4 squared, and that equals 91. There we go, and that equals 91. So to finish this off, look, square root of 91, and we'll write down what that equals there. So the square root of my answer is 9.539. 9.539. There's a few more decimals there, but again, it only said in the question to 2 decimal places, so I'll write it down to at least 3. So we've got 9.539 with a few more decimals as our answer, and 2 decimal places, we'll chop that after the 3, and that's going to equal 9.54, because that 9 rounds it up, and again, that is in centimetres. Need to make sure I read my units this time. There we go. And there is our final answer for this question. Okay, so this says a local charity event is running a raffle to raise money. There is one prize to be won in the raffle. Jenny buys 14 raffle tickets. A total of 450 raffle tickets are sold. Find the probability that Jenny does not win the prize. Okay, so just being careful there, does not win the prize. So if she buys 14 raffle tickets and there are 450 that are sold, the probability that she does win is going to be 14 over 450. Of course, this is asking us the probability that she does not win. So to find out how many tickets she's not got, we would have to do the total, 450, and take away the amount of raffle tickets she bought. Again, we can do this on a calculator, and that comes out as 436. So in terms of the chances of her not winning, there are 436 tickets that she doesn't have out of a total of 450, and that would be the probability of her not winning a prize. Now, this is about probability, so you never have to simplify the fraction when it comes to probability, but of course you wouldn't be wrong to do so. Now, if I simplify that, it does only divide by 2, so it comes out as 218 over 225. But of course, as I said, when you're doing probability, you don't have to simplify the fraction, so there's no point in actually trying to simplify that unless you are specifically asked to. Okay, so this says Ben and Jean each played a game 6 times. Their scores are shown below. So we have a list for Ben's scores and we have a list for Jean's scores. It says compare the median score for Ben and Jean. So if we're going to get the median, then we actually have to write these numbers in order of size.
So for Ben, if we put those in order, we've got 8, 8, 9, 10, 11 and 12. And you can see from this list we've got 6 scores, so the median is going to be in the middle of 2 numbers. So if we go about doing that, we could cross off 1 from either side, and we've got that there are 2 in the middle. So we have to find what's in the middle of those 2 numbers. Now there's 2 ways of doing that. You can either think logically and think what's in between 9 and 10, and hopefully you know that that number is 9.5, or you can add those 2 numbers together and divide it by 2. So 10 plus 9 is 19, divided by 2, you can do on your calculator, comes out as 9.5. So Ben's median is 9.5. Now we'll do the same for Jean and see what their median is. So we've got 2, 4, 7, 10, 10 and 14. So again, if we take the same approach, just crossing off 1 from each side, we'll see that there's 2 in the middle. So we'll look at what's in between 7 and 10. So again, you can just add those 2 together, which I'll do this time. 17 divided by 2, and that comes out as 8.5. So in the middle of 7 and 10, we've got the number 8.5, and that is Jean's median. So if I'm going to compare the median score for Ben and Jean, I would say Ben has a higher median, I'd probably say higher median score than Jean. There we go. And again, I could give the numbers, but as you can see, I've already done the working out. I've made it really nice and clear. Whose is whose. I could even put the names just here, so it's even clearer. But that is nice and clear there. And I could say that Ben's median is 1 higher than Jean's as well. But I've got a limited space, so I'm going to keep it there. And you could obviously explain a little bit more if you wanted to. For part B, it says who had the most consistent scores, Ben or Jean. You must give a reason for your answer. Now when we're looking at consistency, we're looking at essentially of how close their scores are together. So if somebody's getting a very high score, then a very low score, and they're bouncing between these sorts of scores, that would show that they're not very consistent. So in order to look at their consistency, we'll look at their range. So if we look at the range for each person, we'll get the ranges. I'm just going to write them up here next to each person. So for Ben, we'll highlight his highest and lowest scores. So his highest score was 12, and his lowest score was 8. So if we find the range for Ben, that would be 12 minus 8, which is a range of 4. And if we do the same for Jean, we've got the highest score for Jean was 14 and her lowest score was 2. So we've got 14 take away 2, which is a range of 12. So in terms of who was more consistent, you can see that Ben was more consistent. So we would say Ben was more consistent as he had a smaller range of scores. There we go. As he had a smaller range of scores. And there we go. And that would be a comparison for these two. Now, of course, the question could phrase this in different ways. It could just say to compare the scores of Ben and Jean, and therefore we could talk about the median, we could talk about the range, we could mention both of them, but this has split it into 2 parts here where it has to compare the median and then talked about consistency, which is where we look at using the range. So there we go, that's how you go about answering one of these questions, or any variation of this question if it was phrased slightly differently. Okay, so looking at place value. Now in this question, to start with, it says write down the value of 7 in the number 1074. And normally as you say the number, you'll see that I say 74. So the value of that 7 is 70. So we'll just write 70, and that would be the answer for that question. For the next one, we're looking at the decimal places here because it says write down the value of the 3 in the number 16.35. And unfortunately, we don't quite say the number correctly there, but we have to think about what position it's in. And that 3 is in the tenths column. So that is 3/10. So we'd write that down as a fraction. We'd write down 3 over 10. And there we go, that is the value of the 3, that is 3/10. Of course, if we were looking at the 5 there, that's in the hundredths column, so that would be 5/100ths. But there we go, that's looking at a little bit of place value. Okay, so there are 15 pencils in a pack and 40 pens in a box. How many packs of pencils and boxes of pens would we need to buy to have the same amount of each? So we're looking at lowest common multiple, so 15 and 40. I'm going to do a list of their times tables, so 15, 30, 45, 60, 75, 90, 105, 120. And there it is. I know that 40, 80, 120, that's going to be our lowest common multiple there. So the question said how many packs of each, so that is 1 on the top. We've got 1, 2, 3, 4, 5, 6, 7, 8. That was the pencils, so that's 8 packs of pencils. 8 packs of pencils, and below there we have 1, 2, 3, 3 boxes of pens. Okay, so just remember to read the question there, what's it actually asking for in the final step, even though we were looking at lowest common multiple for that one. Let's have a look at the next one. So find the highest common factor of 72 and 90. So we've got different methods of doing this. We can write down 72, we can write down 90 and start finding all their factors. We can of course use the prime factor method, but let's have a look. Let's start with 90. 1 and 90, 2 and 45, 3 and 30. Let's see what else goes in. 4 doesn't go in, 5 does. 5 goes in 18 times. 6 goes in, let's have a think, 15 times. 7 doesn't, 8 doesn't, 9 does, 9 and 10. Now the numbers are right next to each other, so there's no more to look at. So starting with the biggest, let's have a look which one goes in. 90 doesn't, 45 doesn't, 30 doesn't go into 72, does 18. 18 actually goes in 4 times. So 4 times 18, we don't have to do all the factors of 72 there because we've spotted that it's 18. Of course we could use the prime factor method to find the highest common factor, which I'd recommend for numbers like this, so 72 and 90. Do their prime factors, so 8 and 9, 3 and 3, 2 and 4, 2 and 2. 90 is 9 and 10. And then we have 3, 3, 2 and 5. And we can have a look at what's in both. So they both have a 2. They both have a 3, so times 3. They both have another 3. And that's all that they share. 2 times 3 is 6, times 3 again is 18. So we can get our highest common factor using our prime factor method as well. So a washing machine costs £640 plus 20% VAT. James pays a £68 deposit and the rest in 10 equal monthly instalments. Work out the cost of each monthly payment. So it's a percentage of an amount question, so we need to work out 20% of 640. 10% is the most important percentage we ever have to work out, so we can work out everything from there. So we'll work out 10%. 10% is £64. 20% will be double that. So double that is £128, so that's the extra amount he's got to pay for VAT. So if we add these together, 640, add 128, we get £768. Now it says he's going to pay a £68 deposit, so let's take that £68 off because that's what he pays right at the start, and that leaves us with £700. Now it says in the question he's going to pay that in 10 equal monthly instalments. So if we finish this off, if we divide this by 10, so 700 divided by 10 tells us that he's going to pay £70 per month. There you go. So the main part here was the working out the percentage. So always work out 10%, and remember from there you can figure out any percentage. We could have halved 10%, we could have got 5% as 32, or we could have actually divided it by 10, we could have got 1%. Dividing 64 by 10, 1% would have been £6.40, and we could have built that up to any percentage that we wanted from there, so £6.40. Let's have a look at something else. Okay, some error intervals. 6.4 has been rounded to 1 decimal place, and write the error interval. So the error interval, we always tend to put either 6.4 or a letter in the middle, depending on what the question is, and we have our arrows always pointing to the left. So we're going to find the upper and lower bound. Now 6.4, if it's been rounded to 1 decimal place, it couldn't have been 6.45. As soon as that 5 goes after that 4, it would have rounded up to 6.5. So we put that on the right hand side as our biggest possible number, that it couldn't have been 6.45. So it can't be equal to that number, so we leave that symbol as it is. It's got to be less than 6.45. Now what we did there is we added on this extra 0.05, and all we're going to do for the smaller one is take that away, so it would be 6.35. okay, but it can actually be equal to 6.35, so I'm going to add my little equal to symbol on my inequality just there. So it can always be equal to that lower bound, because that would in fact round up to 6.4 if we rounded it to 1 decimal place. On to the next one. This one's slightly different in the wording, so this one says it's been truncated to 1 decimal place, and truncated basically just means it's been chopped off at that after this first decimal, regardless of how it rounded. So if we have a look at writing this as an error interval, again we write these in the same way. The impossible number that it couldn't have been 6.5. So my top one here is 6.5. It had to be 6.4 something if it was just chopped off. Let's imagine just a random how this works. So it could have been 6.4932, but it was just chopped here and we just wrote what was at the start. Okay, but it couldn't have possibly been 6.5 because otherwise we'd have written 6.5. And the smallest it could have been is just 6.4 with no digits after it. It couldn't have been 6.3 though, because again, if we truncate that, it would have just been 6.3. So two different scenarios there. One where you've got to add on that extra 5 at the end and take the same size 5 off the start, and truncating there where we've just got to think about the fact that it was just chopped off and no rounding at all.
Okay, so looking at some money calculations with time. It says James works in a restaurant and the table gives his rates of pay. So we can see Monday to Friday he earns £8.40 per hour, and at the weekend he earns £11.20 per hour. So it says here James worked for 20 hours last week. He worked 8 of these 20 hours at the weekend, show that he was paid less than £200 last week. Well, we want to start by working out potentially the amount that he was paid for the weekend hours. So for the 8 hours he worked on the weekend, he would get £11.20. So if we multiply that by £11.20, we'll just type that in on the calculator. 8 times £11.20 comes out as £89.60. So at the weekend he earned £89.60. That means the remaining hours he worked Monday to Friday. So if he worked 8 of the 20 hours at the weekend, that leaves him with 12 hours that he worked during the week. So for those 12 hours that he worked, he was paid £8.40. So we've got to work out 12 times £8.40. So if we type that in, 12 times £8.40, that comes out as £100.80. So you can already see there that that's going to be less than £200, but it does say show that James was paid less than £200. So we want to make sure we show the working out for this. We do £100.80, and we add to that £89.60. And again, we can just type that in on the calculator, and that comes out as £190.40. So there we go, that is £190.40, and we've shown there that he was paid less than £200. Okay, so looking at length conversions. Now you need to know the conversions here, so we'll just go through a few of these. For part A, it says change 265 centimetres into metres. So you need to know that in every 1 metre, there are 100 centimetres. So that's the fact that you need to know. So to convert 265 centimetres into metres, we would divide that by 100, as there's 100 centimetres in every 1 metre. And that comes out as 2.65 metres. So that'll be our final answer for part A. For part B, it says to change 4.7 kilograms into grams. So you need to know that in every 1 kilogram, there are 1,000 grams. So there we go. In order to convert between them, we'd multiply or divide by 1,000. In this case, we are converting the kilograms into grams. So we're going to get a much larger number, and that is, to do this, we're going to multiply by 1,000. And if we multiply by 1,000, that would be 4,700 grams. And there we go, that is converting kilograms into grams. And of course, the other way around, we would divide by 1,000. For the final question here, we're converting millimetres cubed into centimetres cubed. Now you need to know for this that there are, in every 1 centimetre, there are 10 millimetres. So to convert between centimetres and millimetres, we'd multiply or divide by 10. Now in order to get between millimetres cubed and centimetre cubed, rather than timesing by 10 or dividing by 10, which we would do here, I'm just going to write this down like this, so we would divide by 10 going that way, times by 10 going this way, but when it is a centimetre cubed to a millimetre cubed, instead of dividing and timesing by 10, we divide by 10 cubed and times by 10 cubed. And the same theory applies there. If we're moving between centimetre squared and millimetre squared, we would divide by 10 squared and times by 10 squared. So for this one, we're moving from millimetres to centimetres, so we are going to divide by 10 cubed. So to do that, type it into your calculator and we get 2.4, and that is centimetres cubed. And there we go, that is our final answer. Okay, so looking at some function machines. Now here the number machine says that when you put the input in, you multiply by 3 and then take away 4 and we get the output. So for this first question where it says work out the output when the input is 4, well if the input is 4, when we times it by 3 it becomes 12,
and then when we take away 4, that becomes 8. So for the first one there, our answer will be 8. For the next one, it says work out the input when the output is 11. So if we put the output as 11, we'd have to work backwards. So what was it before we took away 4? Well, to work that out, we can add 4 going backwards. So it must have been 15 before we took away 4. For the next one, it says it was obviously multiplied by 3. So to go backwards through that, we would divide by 3. So what was it when we divide that by 3? We get an input of 5. And the good thing about this, you can check it again going forwards. So 5 times 3 is 15, add 4, take away 4, which was the original function machine there, which gets us to 11. So that works. That must have been an input of 5. Now this final question here is a little bit more complex. So it says show that there is a value of the input for which the output is the same as the input. Or in other words, if we put in 10, we get out 10. Now obviously that's probably not the case for 10, that was just a random guess, but we have to work out a number which gives us the same output. Now there are two ways of doing this. Of course you could just guess a number, so we could say, okay, well if we put in 1, what do we get? Well, times that by 3 is 3, take away 4 is minus 1. So 1 doesn't work, and we could just build it from there. And it might just be that you get it on the second or third guess, but you could also approach this using algebra. We could say, well, if we put x in, what do we get on the outside? We need to get an output of x. So when you times that by 3, you get 3x, and when you take away 4, you get 3x minus 4. And I want that to equal x. So I could write an equation like this, 3x minus 4, and that has to equal x, which was the input. And we could solve it from there. I'm going to show you both ways, because actually it's not too bad to do a trial and error method on here, but this will work no matter what. So when you've got x's on both sides, you have to take away the smallest x. So if we take away x from both sides, you get 2x minus 4 is equal to 0, as we've taken away an x from both sides. If we add the 4 to the other side, again you have to know solving equations for this, 2x is equal to 4, and then divide by 2, you get x equals 2. So as it turns out for this question, it would have only taken me, 2 goes if I started with 1 to find that x is equal to 2. Because obviously after 1, I'd try 2, I'd times it by 3, which would give me 6, I'd take away 4, and I'd get 2. And I'd have got the answer pretty quickly there. But if the input that we were looking for was, say, 10, it might have taken me quite a long time to get there. So obviously having this method of solving equations is very handy for this. But there we go, 2 different methods that you could use to approach a question like this using number machines.
Okay, so moving on to algebra, and we're looking at index laws to start with. So we know with index laws, we've looked at this when we have powers that are getting multiplied together when they have the same base number. These powers can be added together, so 2 and 3 would make 5. We also had the process when they're being divided. So x to the power of 7 divided by x squared, we take away the powers and we get x to the power of 5. And we also have powers in brackets, so if we have x squared to the power of 5, we multiply the powers, so we get x to the power of 10 in that particular example. Now having a look at this one, we've got 30x squared y to the power of 3 on the top and 6xy squared on the bottom. So we're doing a divide. Now we've got these numbers on the top and the bottom, 30 on the top, 6 on the bottom. So numbers always just divide numbers, so 30 divided by 6 gives us 5. Now individually looking at the letters, we've got an x squared, and on the bottom we've got an x. Now it's not written in there, but that is a little power of 1 there that's not written. So if we subtract the powers, 2 take away 1 gives us x to the power of 1. I'm not going to write that in, I'm just going to leave it as x because that means x to the power of 1. Moving on to the y's, we have y to the power of 3, y squared on the bottom, and 3 take away 2 gives us just y on the bottom there. So our final answer would be 5xy. Okay. Looking at this one then, we've got powers in brackets, so we're going to be multiplying powers here. But we've got this number 2 in the start as well, so numbers always get treated like numbers, and that whole thing is being cubed. So we need to work out what 2 cubed is. 2 cubed is 2 times 2 times 2, which is 8. So we're going to have 8 at the start of this one. Multiplying the powers for the x then, x to the power of 2, that's going to get times by 3, so that's going to become x to the power of 6. And y there is a power of 1 which is not written, so 1 times 3 gives us y to the power of 3. And there's our final answer there. Got 2 slightly different ones here that look almost the same because we've got some fractions going on, but let's see how we treat these ones. So on this left, make x the subject. So again, what I could do is I could get rid of this 3 on the bottom to start with if I wanted, or I could get rid of this 5. I'm going to decide to get rid of the 5, so let's take away 5 from both sides. So if we take away 5 from both sides, we get y minus 5
equals x over 3, or x divided by 3. So to reverse a divide by 3, we're going to have to times by 3. So if I multiply both sides by 3, we'll get 3 lots of, and I'll put it in a bracket now, 3 lots of y minus 5 equals x. We could leave it like that, or we could expand this. We could say 3 lots of y is 3y, 3 lots of 5 is 15, copy the symbol, and then put in our x. Again, we could have done that a slightly different way. We could have times by 3 to start with. You'd have just had to remember at the starting point we'd be timesing this by 3, and we'd be timesing this by 3, just like we did in the end there, but that's our final answer. Now looking at this one on the right, it's slightly different because we don't have the option of getting rid of this 5 on the starting process here, because it's locked in by this divide by 3 on the bottom. So the first thing we're going to have to do is times by 3 to remove this fraction to unlock what's on top there. And if we times by 3, we get 3y equals, and what's on the top is x plus 5. Now we can finish it off quite nice and easily. We can just take away that 5, and again that's going to make x the subject, so we have 3y minus 5 equals x, and again both of these questions we could rewrite it as x equals at the start if we wanted. So a equals 5b plus 2c, b equals 3 and y equals negative 2, find the value of a. So we're just having to substitute these numbers in. So we're going to find out what a is. So a is going to equal 5 lots of b, and when I sub a number in I always put it into a bracket, so we have 5 lots of b, which is 5 lots of 3, and then 2 lots of c, so plus 2 lots of negative 2. We put these in a bracket like that. All we have to do is now multiply these. So 5 times 3 is 15. 2 lots of negative 2 is negative 4. And we're adding these together. So 15 add negative 4 is 11. Remembering that these just become a takeaway. So it's 15 take away 4. So a would equal 11. There you go. Just something to remember there. Whenever you're subbing numbers in, always put them into a bracket there, just so that you can sub them in and then deal with the calculations later. So in this question, we're looking at roots and turning points. Now it says here is the graph of, and it gives us the equation, y equals x squared minus 2x minus 4. Write down estimates for the roots of, and when we've got x squared minus 2x minus 4 is equal to 0. Now when a quadratic is equal to 0, that is effectively ground level. It means where does the graph cross the x-axis, and where it crosses are called the roots, and it can also be called the solutions. So we are looking at, and I'll draw it on the graph, this point here and this point here, and they are called the roots and also known as the solutions. So in this question they've used the word roots, and it says estimate because obviously you can just about see it on this graph, so it's not the clearest, so you're just giving your best estimate. Now that one on the left there, from what I can see, looks like minus 1. So I would say x is equal to minus 1. For the one on the right, it's just over 3. So as it is just over 3, I'm going to say 3.2. It looks like it's just crossing the square just afterwards, and it's 5 squares between 3 and 4, so I'll also say x is equal to 3.2. Now the really nasty versions of this question, rather than saying equal to 0, it would say something like equal to 8. And if it wanted to know where it equaled 8, I'd draw a new, not an x-axis, but a new line through 8, just like the x-axis, and I'd read the points here and read the points there. But that's a lot nastier version of the question, but could be asked potentially as well. Part B here says write down the coordinates of the turning point, and again it's the same equation, so we are looking at the point where it turns, which is the point where it stops going down and starts going up. It's the lowest point on the graph, or if the graph was a negative x squared graph where it's shaped like an n instead, we'd be looking at this point right at the top of the graph. But we're looking at the point right down the bottom there, so I just need to read that coordinate, and if I trace up very carefully you can see the x coordinate is 1, so if I write my coordinate, I'll put 1 as the x coordinate. I'm going to go to the left and read this coordinate here very carefully, and that looks like negative 5. It's between negative 4 and negative 6, so it's 1 and minus 5. And there we go. That is how we approach roots and turning points. Okay, so looking at one of these length problems where we have fractions and ratios involved as well. So it says here we have a rectangular wall, and you can see over here it's 6 meters by 1.8 meters. It says Frank is going to cover the wall with rectangular tiles, and each tile is 60 by 30. 3/5 are going to be white, some will be green, the rest will be blue, and the ratio of green to blue is 1 to 3. So we've got 3/5 that are going to be white, and then green to blue is 1 to 3. Assuming that there are no gaps between the tiles, how many tiles of each colour will Frank need? Well, we need to work out how many tiles can actually fit on this wall. And one of the measurements is given to us in centimetres, and over here on the diagram they're given to us in metres. So what we could do is we could convert them. So I would probably write this one as 600 centimetres and 180 centimetres. Obviously just timesing both of those by 100 to turn them into centimetres. Now if we look at the tile, which is 60 by 30, we could think quite logically about how many would fit across. So if the tile, and obviously this isn't drawn to scale, is 60 across and 30 going up, or you can swap it around the other way. In terms of the 60 in relation to the 600, that would mean we could fit 10 tiles going across. Okay, because 10 times 60 would be 600, so we could fit 10 tiles going across. From the 30 to the 180, that's a multiplication of 6. 6 times 30 is 180. Obviously you could type that calculation in on your calculator, 180 divided by 30, but then we know that there's 6 tiles that could fit going up. So there are 10 tiles that can fit going across, 6 tiles that can fit going up. So in total that would be 6 times 10, and that is going to be 60 tiles in total that will fill this wall. So now we know how many tiles there are going to be in total, we can actually start to break it down, look at the fraction, and then look at that ratio. So it says 3/5 are going to be white. So if we work out 3/5 of 60, that's going to tell us how many of them are going to be white. So to work out 3/5, we'd first divide by 5. So 60 divided by 5 is 12. And then we want to times that by 3 because we want 3/5. So that is going to equal 36, and that is the white tiles. So now we know how many white tiles there are, we can start to figure out how many of them are going to be green and how many of them are going to be blue. So the number of green to blue is in the ratio 1 to 3. Well, out of the 60 tiles, we already know that 36 of them are going to be white. So if we do 60, take away the 36, that's going to tell us the total, they're going to be green and blue. So 60 take away 36 is equal to 24, and 24 is now going to have to go in the ratio 1 to 3. So in total, there are 4 parts in that ratio. So if we want to label this up as a ratio, we've got green to blue. It's going to be 1 to 3. There we go, so 1 to 3. So if we divide the 24 tiles by 4, we know that each part is worth 6. So if we multiply both of those by 6, that's going to be 6 green tiles and 18 blue tiles. So there we go, we know that there are going to be, I'm just going to write the letter, so 36 white, there are going to be 6 green, and there are going to be 18 blue. And that'd be our final answer there, 36 white, 6 green, 18 blue. Obviously add those up and they also equate to 60, so we know we've got the full amount there. So there we go, that's how we'd approach one of these problems. Okay, so it says here, write the following numbers in ascending order. Now ascending order means smallest to biggest. So we need to find out which of these is the smallest, which is the biggest, and put them in order. Of course, at the moment we have a decimal, we have a fraction, we have a percentage, another fraction, and another decimal. So it's not very nice to order them as they look. So the best thing to do on a question like this is to turn them all into the same format. Now, you might have noticed on the previous questions, but with all of them we used percentages. So personal preference for me, I like to write them all as a percentage. So first of all, why don't we just try converting them all into a percentage? Of course you could try something else here, but I do think the percentages are the much easier way in order to do this. So for the first one, 0.30, and of course don't forget you can put a 0 at the end there, because then when we multiply that by 100 it gives us 30%. So our first one is 30%. For the second one, we want to turn that into a fraction over 100. Of course, if you just know this already, then that is fine, but 1 over 4 would become 25 over 100. So that one there is 25%. Of course, if you just know that, that's fine as well. You don't have to show the working out for that as long as you're confident with it. Now the third one is already written as a percentage, so that's nice and easy, 28%. The next one's a fraction. So again, let's think about how we would turn that into a percentage. 6 over 25, we would want to multiply the top and bottom by 4 to make it over 100, and 6 times 4 is 24.
so that becomes 24%. And then for our final question here, or our final part of this question, we've got a decimal. So if we times that by 100 and we hop the decimal, it's going to jump over the 9. So that is going to become 29.5. And there's our first part where we've had a decimal inside our percentage, but that's fine as well, it's just 29.5%. So let's get rid of our working out and then let's think about which one of these is the smallest, and then we'll put them in order. Now when you're doing this question, it says write the following numbers in order. It doesn't say to write these percentages in order. So we do have to write the original parts of the question in the appropriate order. But before we do that, I'm going to order them from the smallest. So hopefully you can spot 24% is our first smallest number. We then have 25%, which is our second. Then we have 28%. Then we have 30%. And then actually, I've missed out the 29.5. Our fourth smallest was definitely the 29.5%. And then we have our 30%. So as you've just seen, always be very careful and check that you've read all the numbers carefully. So now we've got that done, let's just write the original parts in order. So the first one was the 24%, and that was 6 over 25. The next one was the 25%, and that was 1 over 4. The next one was 28%, and that was already a percentage, so that's fine to leave it. The next one was the 29.5%, which is 0.295. And the final and biggest part was the 0.3. And there we go, we've written them all in ascending order using our conversions. Okay, so share £240 in the ratio 5 to 7. So if we're splitting this in a ratio, let's have a look. We've got in total here 5 plus 7 equals 12 parts. Okay, so if we split this into 12 parts, we could do 240 and divided by 12. And 240 divided by 12 is 20. So in each part there's £20. Now there was 5 parts and 7 parts, so those 5 parts are going to be 5 lots of 20, which would be £100, and the other part there was 7 parts, and that times 20 would give us £140. So splitting it in the ratio 5 to 7 gives us 100 to 140. And the last little check you can do here is just to add these two together, just to make sure you do get that £240 that you started with. So we're happy with that as a final answer. So Craig and Ian share some money in the ratio 8 to 3. Craig receives £32. How much does Ian receive? Well, C to I, Craig to Ian, was in the ratio 8 to 3. And it said that Craig receives £32. So that is this first number 8 here, that is 32. So what we've got to think about is how do we get from 8 to 32? So 32 divided by 8, which we can do to the side, 32 divided by 8 is 4. So we must have times by 4 to get there. So if we do the same to the other side, times by 4, 3 times 4 is 12. So there we go. How much does Ian receive? Ian receives this 12. So I'll just say £12. Final answer. So Emily and James share some money in the ratio 4 to 7. James receives £21 more than Emily. How much do they share between them? So Emily to James is in the ratio 4 to 7. Now it says that James receives £21 more, and if we look at these two numbers here, from 4 to 7 is an extra 3 parts. There you go, it's an extra 3. So that extra £21 is 3 parts. So if 3 parts of this ratio equals £21, then 1 part must be, to divide that by 3, must be £7. And from there we can work out how much they both receive. If it was 4 to 7, let's get rid of this little bit down here. And each part is now worth £7. Well, 4 times 7 gives us £28 for Emily, and 7 times 7 gives us £49 for James. So Emily receives 28 and James receives 49. It says how much do they share between them? So if we can add these together, it gives us the total amount. So 49 plus 28 gives us 7 and 7, so £77. There we go. So they share £77 between them.
A to B is in the ratio 3 to 5 and B to C is in the ratio 2 to 1. Work out the ratio A to B to C. So if we write out A to B to C and start to write what we've got so far. Now it says A to B is in the ratio 3 to 5 and then it gives us B to C. So there's an overlap in these, there's a B in both. So I can't put another number just over the top of the 5, so I'm going to start a new level. I'm going to write the other one underneath. So B to C is 2 to 1. Now looking at this, if I can make these middle numbers the same, I can merge these ratios together, I can squish them together essentially. So let's think 2 and 5 can make 10. So if we times the top one by 2, that would make that 5 a 10, and we'd have to times the bottom one by 5. So if we times the top one by 2, that 3 becomes a 6, and the 5 becomes a 10. Looking at the one below, timesing that by 5, 2 times 5 makes 10, which we've already got in the middle, and 1 times 5 is 5, and there's my ratio A to B to C, 6 to 10 to 5. Just have a look to see if you can simplify in any of these questions, but it doesn't actually ask us to simplify it there. Okay, so again, there's nothing more complicated in this question, it's just there's a little bit of different wording going on. So it says Maria, Dylan and Kate share £3,000. The ratio of the amount that Maria gets to the amount that Dylan gets is in the ratio 5 to 4, and Kate gets 1.5 times the amount that Dylan gets. Work out the amount of money that Dylan gets. So we want to have a look, how are we actually going to create this ratio? Because at the moment we've got Maria, we've got Dylan, and we've got Kate, but it only tells us the ratio, and that's, so let's just highlight that. Dylan and Maria, or Maria and Dylan, 5 to 4. So we've got 5 to 4 for Maria and Dylan, but we don't know how much Kate gets in terms of parts of the ratio. But it does then say Kate gets 1.5 times the amount that Dylan gets. So Dylan gets 4 parts, so if we times that by 1.5, that actually gives us a value of 6. So Kate is getting 6 parts. Remembering multiplying by 1.5, if you don't have a calculator, just adds an extra half on. Half of 4 is 2, add it on gives us 6. So now that we've multiplied that by 1.5, the rest of the question's nice and easy. Because all we're going to do now is split that £3,000 in the question in the ratio 5 to 4 to 6. So if I get rid of this little bit of working out, this times 1.5, let's have a look. In total, that ratio adds up to 15 parts, and now we know that those 15 parts equal the £3,000. So we can find the value of one part again by dividing by 15, and 3,000 divided by 15 gives us a value of 200. There we go. So they all get 200. So we can go about timesing them all by 200. We're actually only concerned about Dylan in this particular question, and Dylan gets these 4 parts here. So we can just answer that straight away. Dylan's 4 parts, each one of them's 200 quid. So 4 times 200 gives us £800 for Dylan. There we go, and there is our final answer. And again, you could go about obviously finding out the amount that they all get. We could do Maria times 200, which is 1,000, and Kate's times 200, which is 1,200. And you could even add them all together then and show that there's £3,000 there. But that's how we'd approach a slightly different question here. We've got to think about creating the ratio slightly ourselves. David travels from Birmingham to Glasgow. He drives at an average speed of 70 miles an hour for the first 3 hours, and he then drives an extra or a further 150 miles at an average speed of 30. Work out his average speed from Birmingham to Glasgow, so for the whole journey. I'm going to take a similar approach as I did to the density question here, but I'm going to think about obviously using my formula now. So I want to write down my formula, which is speed equals distance over time. And again, we can put that into a formula triangle if we want. And I'm going to do that. So speed equals distance over time. So speed, distance, time. I'm going to use a little formula triangle. So let's see if we can tidy up what we've got here in a little two-way table. And again, for each one, we're going to need a speed, we're going to need a distance, and we're going to need a time. Now we've got the first part of the journey, the second part of the journey, and we've got the total journey. So let's split this all up and write in what we've got so far. Okay, so at the moment we have, he drives at an average speed of 70 miles an hour for the first 3 hours. So this first one here is 3 hours, and he drives at a speed of 70 miles an hour. The second part, it says he drives 150 miles, which is a distance, and he drives at an average speed of 30 miles an hour, so that's going to go just above there. And we want to work out essentially the average speed for the whole journey, which is this one just here. Now again, we can't join together speeds, it's going to be somewhere there in between the 70 and the 30. So let's have a look at what we can do. So this first distance here, let's see if we can work that out. So looking at our formula triangle, distance is speed times time. So we can do speed times time to work out that distance. So 70 times 3, the speed of 70 times 3, says it will go 210 miles. So again, we can add these together to get a total distance at the end there, because that would be 360 miles in total that he's got to do. So all we've got to do is get this total speed here, this total time, and then we'll be able to work out his speed. So looking at this bottom one here, which is the time for the second one. So to get time, you do distance divided by speed. So distance divided by speed will be 150 divided by the speed of 30, which gives us a time there of 5. So that means in total he's going to be driving for 8 hours. Now we can work out his total speed, because we've got his total distance and his total time, and speed is distance over time. So it's 360 divided by the total time of 8 there, and 360 divided by 8 gives us an answer of 45 miles per hour. So I'll just write that down, 45 miles per hour. Again, keeping it all nice and tidy in a table so it all makes sense. Okay, so we've got a little bit more to this question, and as you can see, there's quite a lot of information. So again, let's just have a little read. It says Julie drove from her house to the airport. She waited at the airport and then drove home, and this is her distance time graph. So you can see obviously it looks very similar to the previous ones. So for part A here, it says what is the distance from Julie's home to the airport. So that part there we can read nice and easy. We've got the top part here, and we're going to read that distance, which we can see is 40 kilometres. So we'll write that as 40 kilometres, and again, all these questions are in kilometres, but do make sure that you read the axes because it does say the distance in kilometres. Again, this question here is about the time of day rather than minutes down the bottom, so we actually have to interpret the time. It then says how many minutes did Julie take to get home from the airport. So in terms of getting home from the airport, that's not about the time that she waited, but it is about this distance here, or this journey here. And you can see that when she left the airport, we can get the time, and that time is just down here, that's 3:30. So that's the time that she left the airport, and obviously at the end of the journey, she gets home at 4 o'clock. So in terms of how many minutes it took for Julie to get home, that goes from 3:30 to 4, and that is half an hour. So in minutes, that would be 30 minutes. Again, reading the question carefully, it does say how many minutes, not just how long, so you do have to give that in minutes and not saying half an hour. It then says for part C, and this is our new part here, it says work out Julie's average speed on her journey home from the airport. Give your answer in kilometres per hour. So in terms of working out an average speed, we need to remember our speed distance time formula. And we have all the information already in order to work that out, we just need to be careful when we're using it. So our speed distance time formula is that speed is equal to distance over time. And remember, if you like, you can put that into a formula triangle. So if I write the formula triangle over here, that is that speed is equal to distance divided by time. Now we need to be careful on this question because it does say to give it in kilometres per hour. And for the previous part, we just wrote down that the time was 30 minutes. And when we are working with kilometres per hour, we need to make sure we write that in terms of an hour. So we'll discuss that in just a second. But let's think about the two bits of information. So we need the distance. Now the distance at that point on the journey, we've actually already written down. We've got that was 40 kilometres. So we know we're going to do 40 and we're going to divide it by the time. And the time we have already got as well. We have got the time from this part of the journey down here, which was 30 minutes. But we need to write that in hours. Now this is not a nasty amount of minutes to write in hours because you should hopefully know that that is half an hour, which can be written as 0.5. But if you are struggling on one of those, particularly if it's a harder amount of minutes, then you need to know how to turn that into an hour. And the way to do that is just to write it as a fraction. So we think about an hour, which is 60 minutes in total, and here we have 30 minutes. So that is going to be 30 minutes out of 60 minutes. And if you type that into your calculator, it comes out as 0.5. Now for these questions, you can use a calculator to do these conversions, but just be aware that sometimes, potentially with a 0.5, that's going to be potentially a question that would be non-calculator. So you do need to know how to convert some of the easier ones, because you could simplify the fraction, which would become 3/6 and then 1/2. So it's not too bad to turn that into an hour. But for this one here, we need to do 40 divided by 0.5, and that is going to come out as 80. So we have an answer of 80, and that is in kilometres per hour. So we would write kilometres and then /hour, kilometres per hour. And that would be our final answer. Okay, so looking at a question where we are describing shapes. So it says Robin is describing a shape to her friend Lily. Robin says the shape has 4 sides and it only has 1 pair of parallel sides. What shape is Robin describing? So obviously you need to know your shapes very well here. It's got 4 sides, so it's a quadrilateral. So you just need to think about drawing some of the shapes and thinking about if it matches this criteria. Now for this one here, 1 pair of parallel sides, that is only one possible shape, and it's a trapezium. So a trapezium looks like this. We've got the parallel side on the top and the bottom, but the other pairs of sides are not the same. And obviously you can also have a right angled trapezium as well, where it looks something like this. We've got a couple of right angles, but we also have just 1 pair of parallel sides. So for the shape that we are describing for this one, we're looking at a trapezium. So there we go, we would write a trapezium. Now the second one here is a bit of a strange question. It says Lily says the shape has 4 sides and it has 2 pairs of equal opposite sides, and the opposite sides are parallel. Now this is a bit of an ambiguous question because of the way that it's phrased. So we could think about the most obvious ones, which is a rectangle and also a parallelogram. Now a rectangle and a parallelogram have 2 pairs of equal opposite sides. You've got the top and the bottom on a rectangle, which are parallel, and you've also got the sides, which are equal and opposite as well. And that falls true with the parallelogram. You've got the top and the bottom, which are parallel and equal, and then you've got the sides, which are also parallel and equal. So to be fair, based on however you read this, maybe there's only 2, but we're going to discuss this a little bit further, because also you have a square and you have a rhombus. It's a little bit harder to draw a rhombus and not make it look like a parallelogram, but they have exactly the same properties. You've got 2 pairs of equal opposite sides, and the opposite sides are parallel. But this wording, 2 pairs of equal opposite sides, could be that the 2 sides are opposite, but not all 4 are equal as well. So with a square and a rhombus, all 4 sides are also equal as well. So they do have 2 pairs of equal sides, but actually all 4 are equal. So for this particular question, you could actually say yes or no, just because of the way that it's phrased. But you would have to obviously explain that. So you could say yes, because a rectangle and a parallelogram have 2 pairs of equal opposite sides, but you could also actually say no, because actually a square and a rhombus do as well. But it just depends on how you read that question. So it's a bit of a strange one. I'm just going to say yes. So I'm going to say yes, and we're going to say a rectangle and a parallelogram. But just a note on this one that, to be fair, because the wording of this is a little bit strange, you could actually make the argument of no and say that there's also a square and a rhombus. So a little bit of a strange question there, but there you go, one for you to have a little think about. Okay, so a question thinking about rotational and lines of symmetry. So it says here is a quadrilateral, write down the order of rotational symmetry of this quadrilateral. So the order of rotational symmetry means if we were to rotate it, normally around the centre, so around this central point, how many times would it take to turn it back to its original position? But along the way, are there any points where it would look exactly the same as we turn it? So obviously as we turn it 90 degrees, you would end up with this quadrilateral in this position here. So it doesn't look perfectly the same, so that wouldn't count. As we get round to 180 degrees, it would look exactly the same. So it would get to this point, and that would be an order of 1 by that position. If we rotate it another 90 degrees, it would go back to this position, this first one, so that wouldn't be the same. And then we rotate it one more turn of 90 degrees, and it gets back to its original position. So it would have an order of rotational symmetry of 2. Once where it gets to basically upside down, and then the final turn where it gets back to its original position. So we have an order of rotational symmetry of 2. And therefore any shape, if you think about this, any shape is always going to have an order of rotational symmetry of 1, because it will always go back to its original position. So we're just thinking about how many more times on top of 1 will it be in the same position as you rotate it around. Now the next part here, it says write down the number of lines of symmetry for this quadrilateral. So we're thinking about any mirror lines that we could draw on there where the reflection is the same either side of the mirror line. And hopefully you know your lines of symmetry fairly well, because hopefully you can see that if you were to draw a mirror line in here, it's exactly the same above and below. So it's definitely got one line of symmetry. Now it also has another line of symmetry where we're going straight down the middle. And there we go. That means we've also got another line of symmetry. So we've got 2 in total. Now, sometimes people might think there are some diagonal ones. That's not actually the same there on either side of that diagonal. So you have to be very, very careful, but just make sure you get those obvious ones and then just see if there are any more. So this particular shape only has 2 lines of symmetry, where it's the same above and below that red line and left and right of that green line. So when we're looking at circles, there's 2 formulas that we need to know. Circumference equals pi times diameter, and area equals pi r squared. Remember the units for area have squared in, don't they? When we use centimetres, we have centimetre squared. So I always like to remember the little formula for area there is the pi r squared, the one with the squared in. So we're going to work out the area and the circumference of this circle. So to work out the area, we're going to do pi r squared if we start with that. So the area equals pi r squared. And we just need to know what the radius is. So over here, the diameter is 8. So we're going to first halve that for the radius. So I'll just write r equals 4. And we've just got to type that in. So pi times 4 squared. 4 squared is 16, so it'd be pi times 16. And you can just write that as 16 pi. So if it asks you to give your answer in terms of pi, you can just do that. But we want to type that into our calculator if not. So 16 times pi will give us a decimal, which is 50 point. I'm going to round this, but obviously only round it if it says to in the question. It'd be 50.27 if I round it, centimetres squared. And that would be an area there to 2 decimal places. Let's have a look at working out the circumference. So circumference up here is pi times diameter. Now we've been given the diameter is 8. So to get the circumference, we just do pi times 8. And we could just say 8 pi. So we could just say 8 pi, which just means pi times 8. But again, if it asks us to work it out, we're going to do pi times 8 on the calculator. So 8 pi, press equals, and we get, and if I round this to 1 decimal place this time, I get 25.1. And circumference is a distance, it's around the outside, so it's just centimetres, 25.1 centimetres. But again, rounding it to how the question asks, and remembering you can write it in terms of pi, like down here 16 pi, and up here 8 pi as well. So surface area of a cylinder is a little bit more complicated because we've got these 2 circles to work out, and then we've got this shape wrapped around the outside of the cylinder. So the area of the circle we've actually already worked out. Pi times r squared is 16 pi, and that equals the circle. Okay, and not forgetting we've got 2 of those. So let's times that by 2, which gives us 32 pi, which again is a number, but I'm just going to leave it till the end for the area of my 2 circles. Now the next thing that I have is this shape wrapped around the outside, and if we were to unravel that, we'd have a nice big rectangle, and the height of that rectangle there is 15. The length of the rectangle is actually the circumference of the circle. So we just looked at circumference of a circle. The circumference is pi times diameter. So I'll do 8 times pi, or 8 pi, the diameter there being 8. It's given us a radius of 4, so we could put the diameter equals 8. But that's 8 pi for the length. And we work out the area of a rectangle just by doing length times width. So to work out the area of this, we'll do 15 times the 8 pi. And that gives us 120 pi for the area of that rectangular part wrapped around the outside. All we've got to do to finish this off is add these 2 together. So we have 32 pi, add 120 pi, and in total that gives us 152 pi. Again, we could just write this as a decimal, but 152 pi comes out as 477.5 to 1 decimal place centimetres squared for surface area, and there's our final answer. So you just got to remember, you obviously got the circles top and bottom, and then to work out the area of the curved part, you need to think about that circumference there being the length of the rectangle. Next one here we have a hemisphere, and it says work out the volume of the hemisphere. Now again we'd be given the formula to work out the volume of a hemisphere, and volume of a hemisphere is 4/3 pi r cubed, and that is our final volume there. Oh, let's make sure that says, that's a rubbish 3, let's change that. 4/3 pi r cubed. So all you've got to do is stick the numbers in the formula again. So if I want to work out the volume, all I have to do is in the calculator I do 4/3 multiplied by pi multiplied by 8 cubed, and we'll get our answer here straight away. So fraction button, 4/3 multiplied by pi multiplied by 8 to the power of 3. And we get a volume here of 2144.66, again if I round it to 2 decimal places, centimetres cubed. Just remember obviously to write all the numbers down and only round it once you've been asked to. Okay, so once you've got your total volume of your sphere there, just remember this is a hemisphere, so it's half the size of a sphere, exactly half. So I just need to divide my answer by 2 here. And once we divide that by 2, we get a final answer of, let's have a look, 1072, so 1072.33. Again, I've rounded it there, centimetres cubed. And that would be your final answer here for the volume of a hemisphere. Not forgetting as well, you could be asked to work out the surface area. And if you're asked to work out the surface area, again, it gives you the formula of a sphere. And the surface area of a sphere is 4 pi r squared. So again, if I was to work out the surface area of this one, it's a little bit more complicated, but only in the sense that we work out the full surface area. So we do 4 times pi times 8 squared. If I just go for this, let's work it out. 4 times pi times 8 squared. That gives us a surface area of a sphere being 804, and it's 0.25 as well. Again, we'd have to halve it because it's half. Okay, so half of that would give us a surface area of 402.12. And that is obviously a surface area, so it's centimetre squared. But if you're working out surface area, you've got to make sure you don't forget as well the circle sitting on top there, because it's the total surface. And the area of a circle is pi r squared. So we can work out the area of the circle as well. And if we just do that, pi times 8 squared, we get an area of the circle there of 201.06. And you would just add these two numbers together to get the total surface area. So if you add 201.06, we get a total surface area of 102.12 added to that gives us 603.18 centimetres squared. Again, so I know we were looking at volume there, but just thinking about if you had to do the surface area as well, how you'd approach that when you've got a hemisphere and you've got to make sure you halve them and add on the extra circle. Okay, so looking at trigonometry. Now the hint that we're going to be using trigonometry is we've got a right angled triangle and there's an angle within them. So looking at this one on the left to start with, because we're going to work out the missing length in these two triangles, I'm going to start with this one on the left. So we've got an angle of 43, and the only thing I have to remember here is how to spell SOHCAHTOA. So SOHCAHTOA. There we go. Now that's just going to help me to know which I'm going to use, whether I'm going to use sin, cos or tan. So the first thing I need to do is I need to label this triangle to see what sides we've got. So opposite the angle that we're using, that's called the opposite. The longest side, which is opposite the right angle, is always called the hypotenuse. And the final side there is called the adjacent. Now there's one of the sides here I don't need to be thinking about. I need to use the opposite. I'm looking for the hypotenuse, so I don't need the adjacent. So let's have a look at what formula triangle we're going to use. Well, O and H, opposite and hypotenuse, is within my sine triangle there, SOH. We've got O and H within that triangle, so I'm going to use SOHCAHTOA. The part of SOHCAHTOA I'm going to use is sine. Now the side that I'm looking for is the hypotenuse up here with the x next to it. So hopefully you're used to using formula triangles. I'm going to cover up the H. Okay, so the sum that I need to do to find the hypotenuse is O over S, or O divided by S. So that's O divided by sine. So to find the hypotenuse, I'm going to do the opposite, which is 6, and I'm going to divide it by sine. All I need to remember is to put the angle here, 43, with sine. So sine 43. So sine 43 tells me the relationship between the opposite and hypotenuse. In this case, we're going to do a divide. O on the top, S on the bottom. Don't forget to put 43 in the bracket there for some of your calculators. So 6 divided by sine 43 on the calculator. 6 over sine 43 is 8.79 centimetres. I'm going to round that to 2 decimal places, and it actually comes out as, if I write a few down, it's 8.7976. The question will tell you how to round it. So if I round it to 2 decimal places, that would be 8.8 actually, 8.8 or 8.80. Let's round it to 1 decimal place. So we've got 8.8 centimetres for that first question. Now if we have a look at the one on the right, so question 2, we've got a very similar process here. Let's have a look. So we still have a look at our angle, label the sides, so opposite that is our opposite. And then we've got the hypotenuse here. And again, the adjacent ends up being down the bottom based on where that angle is. Now again, we need the opposite because that's the one we're looking for. We need the hypotenuse because that's given to us, but we don't need the adjacent again. So again, I'm going to be using my sine triangle because I've got O and H. I'm going to rewrite it again. So I've got SOH, but this time we are looking for the opposite. So I'm going to do the same process again. I'm going to cross off the opposite, and that tells me that I'm going to do a times. I'm going to do S times H. Now S again stands for sine. I just need to put the angle with it. So this time it's 36. So sine 36, making sure you put it in a bracket again, times by the hypotenuse, which is here, which is 9. So sine 36 times 9. And again, typing that into a calculator, sine 36 times 9 gives me an answer of 5 point, and if I round it to one decimal place again, well, it comes out as 5.29. So to one decimal place, that would be 5.3 centimetres. And again, just thinking logically here about whether your answer makes sense, because it can't be longer than the hypotenuse there, so it can't be longer than 9. So you should know if you've done it wrong, because it might end up coming out longer than 9. So that's finding side lengths using SOHCAHTOA. When it comes to finding an angle, we've got a very similar process. I'm going to have a look at this question. It says find the sides of angle ABC. So from A to B to C, that gives us this angle down here. And again, I'm going to follow the same process. So opposite that angle is over here. Our hypotenuse is opposite the right angle, and our adjacent side is down here. So it looks like I've got a different bit of SOHCAHTOA to use this time, because this time I don't need the opposite, but I do need the hypotenuse and the adjacent. So again, just write down SOHCAHTOA, and we're looking for the formula triangle, this time that has the H and the A in, the hypotenuse and the adjacent. So the H and the A is in my cos triangle, so I'm going to be using this one. Now we're looking for the angle this time, so if I cover up the angle part, which is the C, it tells me that I need to do A over H. Now if we just do that, A is 7 and H is 13. Now if I just type that into the calculator, 7 divided by 13 just gives me a decimal 0.538. Now the calculator doesn't know that this time I'm looking for an angle, so all I'm going to do to tell the calculator I'm looking for an angle is first I'm going to press Shift and then press cos, so shift cos. And on your calculator it'll come up with, and let's get it on my calculator here, you get it saying cos -1. And that just tells your calculator, this time I'm looking for the angle, and this is the fraction I want to put in. So you type in cos -1, and then 7 over 13. And if your calculator has the fraction function, you can put it in as a fraction. If not, in the bracket there, just put 7 divided by 13. So let's do that, cos -1, 7 divided by 13, or 7 over 13 is a fraction, and you get the answer here, 57.42. And if we round that to one decimal place, it'd be 57.4 degrees. There we go, for an angle. So it's the same process no matter which formula triangle you use. You just have to identify the sides, and then when you're looking for an angle, you're always going to press Shift cos, Shift sine, or Shift tan, and you'll get this little symbol here, cos -1. Okay, so I've got a slightly more complicated question here. It says work out the size of angle BAD, and angle BAD is the full angle right here. Now that's going to be quite difficult for us to work out, but just like on previous questions here, when we've looked at Pythagoras and trigonometry, we can chop this across the top, look, and that's going to be where we find our little right-angled triangle. And if we chop this across, we now know part of the angle there, because that's a rectangle, so part of it is 90. So we just need to find out what this little angle is just here. And we can do that if we've got 2 of the side lengths. Now we've definitely got one of them, because we've got 15 down the bottom, so this must be 15 here, 15 metres. And we've got 6 along the top here. Now we know, because it's a rectangle with the 4 over here, that this must also be 4. So this little bit on top must be 2, because that gives us a total of 6 there. So now we've got our right angle triangle. We've got the opposite side over here, which is 2. So let's label that as the opposite. And we've got the adjacent side down here, which is 15. But again, we didn't need the hypotenuse, so we don't need to worry about the hypotenuse there. So we've got O and A, and that is again in our tan formula triangle, so TOA. And again, we're trying to work out the angle, so it's O over A when we cross out the T. So we go for tan -1, O over A, O being 2, the adjacent being 15. And if we type that in, shift tan, 2 over 15, and that equals 7.5946 with a few more decimals, or to one decimal place, that's 7.62. degrees, and that is the angle for the size of x there. Now this question obviously wants us to find the full angle, BAD, so we've got the 7.6 in this little place here, which is a very small angle there, 7.6 degrees, and also the 90 degrees here that we've got in the rectangle. So adding them both together, 90 plus 7.6 gives us a final answer, which I'll write over here, of 97.6 degrees, and there is the final answer for our question there. Okay, so this question says a square has an area of 81 centimetres squared. Work out the perimeter of the square. Now when we're looking at perimeter, that's the distance all the way around the outside. So for a square, we know all the sides are equal, so we just need to find what the side length is of the square, and then we can add them all up. So if the area is 81, we're thinking what number times by itself, because we've got a length times width for the area of a square, is going to equal 81. And hopefully you can spot that that is 9. It's 9 times 9, which will give us an area of 81. When it comes to a square, you could actually just do the square root of 81. That's obviously figuring out what number times itself makes 81, and that would give you the answer 9. So we know the side length is 9, so to get the perimeter, we want all 4 of those 9s. We just want to add them all up. So you could do 9 times 4, or you could just write down 9 plus 9 plus 9 plus another 9, and that is equal to 36. And as it is perimeter, we want to give the units as a length, so that would be 36 centimetres, as our area was centimetres squared, therefore our length was also in centimetres. So there we go, that's our final answer, 36 centimetres, that's the perimeter of the square. Okay, so this question is slightly different, not necessarily looking at a functional question, although it is the diagram of a floor plan. So it says here we have a floor plan, and the area of the floor is 138 metres squared. And it says work out the value of x, and x is this length down here. So in order to work this out, we're going to have to think about what we're actually missing and what information we have been given. So we've been told the total area. Now if we split the shape up, and again you could split this into either direction, if I split it across that way, then what could we work out? Well, we could work out the area of the larger rectangle on top. And we could then potentially work out the area of the rectangle on the bottom as well, but we're trying to find out what that missing length is. So if we go about trying to work this out, let's just have a think about what we'd get. Again, you could have split it going up and down, but we've just picked this one, so let's just see how this ends up. So for the top rectangle there, we would do the length times the width, which is 8 times 15. And if we work that out, let's see what we get. We get 8 times 15, and that comes out as 120 metres squared. So if that part is 120 metres squared, and the total area is 138, well, if we do 138 and we take away 120, that leaves us with an area left over of 18 metres squared. So looking at that bottom rectangle there, we have a width of 3. So what length would we need to have in order to get an area of 18? Well, we know it's going to be 3 times something, and that is going to give us 18. And hopefully you've spotted that that number would have to be 6. And again, you could reverse that by doing 18 divided by 3. So we know that this length down here is 6 metres, so now we should be able to work out that value of x, because this distance all the way along the top is 15, and we've got the part of that distance just here is 6, so if we do 15 take away the 6, it will tell us this remaining length here that's going to make it add up to 15. So 15 take away 6 would give us a length of 9. So the value of x must be 9, and that is already in metres, so x is equal to 9. And there we go, that would be our final answer. So as you can see, sometimes with these compound area shapes, you would have to work out a missing length by thinking about that in a different way. And that's just another method for some of these compound area questions. Okay, so working out the size of angle x, again I've got 2 here, and we're looking at parallel lines. As you can see by these arrows here, these lines are parallel. So there are 3 rules that we're going to really look at when we're looking at parallel lines, as well as all our normal angle rules. We've got alternate angles, corresponding angles, and co-interior angles. So if we look at this one on the left here, 110, there's lots of angles we can find now. So all around this point here, we can find all of these angles. Vertically opposite the 110 is also 110, and then next to the 110 on the straight line there, remembering angles in a straight line add up to 180, these would all be 70. There we go. So it's up to you really how you actually find this final one. I'm going to have a look at finding this Z shape here, which is an alternate angle, and alternate angles are equal. So this 70 here is the same as this 70 here. So x would equal 70 degrees in this one. And we've normally been asked to give our reasons there. So my reason may have been angles on a straight line equal 180, and that's how I got the 70. And then I would have said alternate angles are equal, and that's really important the way you say that. So alternate angles are equal. Okay, there are also other ways that I could have done that. If I flick to another colour, we could have said, okay, well, if this is 110, well, then this here is also 110 because those angles are corresponding. And again, I'll try and draw this on a different colour, but they make this F shape, okay? So that 110 and that other 110 are corresponding angles. So we could have done it that way and then done angles on a straight line. Let's have a look at this other one. So 105 degrees down in the bottom here. So straight away, just above that, we can find that this angle's 75 because angles on a straight line equal 180. Now, if you have a look, we've got a triangle in this question. Now, there's these two symbols here, which tell us that this is an isosceles triangle, and base angles in an isosceles are equal, and it's underneath these two little, what I call little eyebrows. Okay, so underneath, this will also be 75 because base angles in an isosceles are equal. We can then find this missing angle here because angles in a triangle equal 180. So those two 75s equal 150. And if we take that away from 180, it leaves us with the other angle in that triangle being 30. There we go. And there's all the angles that we found just using basic angle facts. Now, to get that angle x, there's a couple of ways we could do it. We could find this angle here and then do angles on a straight line. Or we could again identify that actually we've got one of these alternate angles going up, making this Z shape again. So that's an alternate angle with the 30. So that's 30 degrees as well. So for this one, we'd say x equals 30. And again, we'd probably give this same reason over here that alternate angles are equal. Unless, of course, we took a different approach, which we could have done. Again, lots of different ways that you can tackle these questions, but a few there that you need to make sure that you try and remember. Okay, so a slightly different question here. We've got some negatives in our vectors. We've got a negative on the top of A and a negative on the bottom of B. So that indicates a left movement of 2 there for vector A and a down movement of 1 for vector B. And it wants us here to write down 2A minus B as a vector. So we're going to do the vector 2A. So let's do that one to start with. We've got 2 lots of, and then we have minus 2 and 5. And we're going to take away from that vector B, which is 3 and minus 1. Okay, let's sort out this 2 lots of vector A to start with. So doubling both of those, we have minus 4 over 10. Okay, so just doubling those, and we're going to take away this 3 over minus 1. Now, we're going to deal with the top numbers to start with. So let's just think about this numerically. We've got minus 4, and we're going to take away this time, we're going to take away 3. So minus 4, take away 3, leaves us with minus 7. And on the bottom there, we just need to be careful because we're going to be doing 10 and we're going to take away that negative 1 on the bottom. So taking away a negative, that's obviously going to add 1. So actually we're going to do 10 add 1 here, and that's going to be 11. And there we go. There is our final vector, minus 7 over 11, written as a column vector. Okay, so for these next few questions, we've got some visual vectors that we can actually see drawn on a grid. And it says in the question here, the vector A and B are shown on the grid. And we've got vector A that we can see there going sort of upwards to the right, and vector B that we've got going downwards to the right as well. And it says for part A here, on the grid, draw and label the vector minus 2A. Now obviously 2A will just be double the distance of A. The fact that it's put a minus in there means it's going in the opposite direction. So instead of our arrow pointing upwards, it's going to be kind of coming downwards to the left. So in terms of looking at this, we just need to establish what the pattern is of A just to make sure that we draw this in correctly. And you can kind of see if we start from a certain point, we need to go across 1 and we go up 2. There we go, let's draw that again. So we go across 1 and we go up 2. Right, so in terms of actually getting the pattern here, we just need to pick somewhere, hopefully not somewhere where it's going to overlap with A. So let's start down here. There we go. And we're going to go across 1 up 2, which gets us to there, across 1 up 2 again, and that will get us to there. Okay, so let's rub that out. So in terms of actually drawing the line in, that would be the vector 2A, double the distance of A and following that same pattern across 1 up 2. The fact that we're doing minus 2A just means we need to point the arrow in the opposite direction. So there we go, we can label that. That would be the vector minus 2A. And there we go, there's part A done for that one. Now for the other one, we've got to work out the vector A plus 2B as a column vector. And the process of looking at the pattern is really going to help us for this. So we looked at the vector A to start with. Now that vector A, and we can write this down over here, the vector A, it went across 1 and up 2. So that would be 1 in the positive right direction and then 2 obviously being a positive in the moving upwards. So there's our vector A, 1 over 2. Now the vector B, let's have a look at that one. So from the start, obviously it's going downwards, this one as shown by the arrow. That's going to go across 1, so a positive 1, and then it goes down by 3, so that'll be negative 3. So the vector B, if we write that in, B is equal to 1 over minus 3. So now we've established that, we can just treat that like we did in those earlier questions. We're going to do an A, and we're going to add to that 2 B's. So in terms of writing this one out, we've got A, which is 1 over 2, and we're going to add to that 2 of the B's. So that's going to be 2 lots of 1 on the top, which is 2, and 2 lots of minus 3 on the bottom, which is minus 6. There we go, and we can add those together. So 1 plus 2 on the top gives us 3, and then 2 add negative 6 on the bottom. Well, when we add negative, that's going to take that away, so that'll be minus 4 on the bottom. So our final vector will be 3 over negative 4. And there we go, that's how we're going to approach these vectors when they're on a graph. Obviously we can just turn the vector into a column vector and treat it just like we did on the previous questions. Okay, the table shows the probability of picking different colours. So we have red, blue, white and black, and it says the probability of white and black is the same, complete the table. So at the moment we've got these two which add up to 0.7, and probabilities have to add up to 1. Now what we've got left over there is 0.3. I like to think of it as 0.30 because if they're both the same, we're going to have to halve that, and half of 30 is 15, so it's 0.15 for both of those, and now they add up to 1. Now for part B, it says that there are 60 counters in the bag. How many are white? Now if we look at the probability of white, which is over here, 0.15 is 15%. So really all this is asking us to do is to work out 15% of 60. And we can do that nice and easy. 10% is 6. 5% is half of that, which is 3, and add them both together, and that's 9. Now part C here, you won't be given this at the same time as question B because we already know that there are 60 counters in the bag, but it says that there are 12 red counters, and how many counters are now in the bag. So if we imagine this is a completely different question now, but it's saying that red counters here, which is 20%, is now 12 counters. So all that's actually saying is 20% equals 12 counters. Now that's okay, we can turn that back into 100% quite nice and easy. I could just times that by 5, but let's imagine it's not a nice percentage. I'd have to try and break it down to something which turns into 100. So we could divide it by 2, which would give us 10%, which is half of 12, which is 6, and then times that by 10 to get us back to 100%. Okay, again, you could actually just times 20% by 5, but I think that's quite nice just to break it down and build it back up. So 60 counters there would be in the bag. Okay, so we've got a lot of information here. 100 students are in a year group, and then we've got some information about whether they wear or do not wear glasses. And it wants us to work out the probability of choosing a boy who wears glasses. And when you've got a lot of information like this, I like to organise it in a two-way table. So I'm going to put this all into a two-way table. Again, you could use a frequency tree, but I'm just going to opt for using a two-way table. So we could have boys and girls on the side. Again, you could have them at the top, but I'm going to put them to the side. And then you've got a total down the bottom. And then we've got whether they wear or do not wear glasses. And again, we've got a total here. So all I'm going to do is put the numbers within the question. We've got 100 students in the year group. 42 of them are boys. 8 out of 100 students wear glasses. So 8 students here wear glasses. And 52 of the girls do not wear glasses. So 52 just here. Now that's everything in the question. We've just got to fill in all the missing numbers now. So if there are 42 boys here, that must mean that there are 58 girls. And out of those, 52 do not wear glasses. So that must mean that 6 of them do. Now again, we've got 8 that do wear glasses, 6 of them are girls, so 2 boys must wear glasses. And again, going along this way, that has to add up to 42, so that must be 40. And then moving downwards or across from another direction, I could add those together to make 92. And a very quick check here, those two add up to 100, so that's right, we're happy with that, we can tick that off. Now it says, work out the probability of choosing a boy who wears glasses, and one of the students is picked at random, while 2 of the boys wear glasses. So that would be 2 students out of the 100 students that we've got here. You don't have to simplify that, but just a quick note, it could have said in the wording here, it could have said, rather than saying one of the students, it could have said one of the boys. Now if it had said it, maybe it had picked one of the boys, then that would have been out of 42. So it would have been 2 over 42. But it just depends on what the wording says. So it does say one of the students. It doesn't dictate whether it's boys or girls, so it's out of 100. Okay, so looking at a line graph, it says in Adam's garden, the flowers are only red, white, yellow or blue. And you can already see on the graph here, we've got red, white and yellow, but we're missing the blue. So it says the chart shows, and obviously just what I've said there, it shows the number of red, white and yellow. And it says the total number of flowers is 30. So the total number is 30, work out the number of blue flowers. So we want to work out from this graph how many are red, how many are white, how many are yellow, and then we'll figure out the difference there to see how many are blue. So you can see red, if we go across, falls on 8, so there are 8 red, so we'll put 8 there. We go across from white, and that lands on 10, so 8 plus 10. And then if we go across from yellow, that's in between 4 and 6, that's going to be 5. So we've got 8 plus 10 plus 5, that adds up to 23. So we know that there's a total of 30. So if we do 30, take away the total of red, white and yellow, which we've worked out to be 23, that leaves us with 7. So there must be 7 blue flowers, as it does say in that first line there, only red, white, yellow or blue. So all those remaining flowers must be blue, and therefore our answer is 7 blue. Okay, so this is a relatively tricky question, but it's asking us to work out the mean from a graph. It says here that Fran asked each of 40 students how many books they bought last year. Show that an estimate for the mean number of books bought is 9.5, and you must show what you're working. Now normally when we're working out the mean and we have these sorts of bits of data down here called grouped data, we'd normally put that in a table. So we would normally write, I'm going to draw like a pretty basic table here, but we would normally say sort of like 0 to 4, I've always written 0.4, let's just change that, 0 to 4, that's our category, I'm going to write it again, 0 to 4, and then we've got 5 to 9, 10 to 14, 15 to 19, and we've got 20 to 24. And normally when we are doing mean from a table, when we've got grouped data, we do the midpoint and times by how many there are. So for each one of these bars, we want to figure out how many there are, so we can actually go about doing that. So for the first bar, we're between 10 and 12, so that's 11. There we go, so we've got 11 books between 0 and 4. 11 people that bought books between 0 and 4 books. For the next one, that lands on 8. So 8 people that had between 5 and 9 books. For the next one, that's between 12 and 14. So that's 13 people that had between 10 and 14 books. For the next one, there we go, we've got 6 people between 15 and 19 books. And for the last one there, we've got only 2 people that had between 20 and 24 books. So that's all the data that we've got from the table. Now we want to actually go about finding mean from a table just in a way that we normally would. So we'll take the midpoint, so I'm going to write those in. So the midpoint of this one is 2, the midpoint of 5 to 9 is 7, from 10 to 14 is 12, from 15 to 19 is 17, and for the last one there from 20 to 24 is 22. So we're going to multiply that midpoint by how many people there were, and that'll give us our total, or an estimated total. So 2 times 11 is 22. Obviously don't forget, you have got a calculator for this, so you can always work these out on the calculator. 7 times 8 is 56. You've got 12 multiplied by 13, which is 156. There we go. You've got 17 multiplied by 6, that's 102. And then you've got 2 times 22, which is 44. So that's our estimated amount of books that people have had. So if we look at this then, we want to add all of those together to get our total. So again on the calculator, we've got 22, add 56, add 156, add 102, and then add 44, and that gives us an overall total of 380. Now, a big mistake that people make is they divide that by how many groups there are. So they might divide that by 5, but of course we want to divide by how many people there are. And in total, and we were told in the question, there are 40 students. So we would divide that by 40. So 380 divided by 40, and that gives us an answer, again on your calculator, of 9.5. So there we go, that's shown that that's 9.5. So this is a very unique question. We are finding the mean from a graph, but because it was grouped data, as we can see from the bottom there, we have to find the midpoint and then multiply that across to get our estimated totals and then find our estimated mean. So there we go, that is the answer to that question, and a useful video to watch on that would be averages from grouped data. Okay, well done for making it to the end of the video. Hopefully you have already checked out the video that's on screen with my final predicted paper, and you've also gone through all the unseen topics video, going through one question on every topic on that checklist. Hopefully you found this video useful and helpful. Obviously I do wish you the best of luck in this final exam. Please don't forget to come back on results day and let me know how you've done, because I will be eagerly awaiting on results day to find out how everyone's got on. But otherwise, I do wish you the best of luck, and hopefully I'll see you for the next one.